Okay, great everybody. Welcome to the session. Welcome to the DevOps Foundation course from DevOps University. Myself, Naresh, and I'll be the instructor for this course. The next 5 session will be conducting for you on this one. So hope everybody is able to hear my team. So I hope you're all good, doing great. So just for a quick introduction about myself, team again, myself Naresh. I'll I'll be the instructor for this one. I have over a decade of experience in IT industry, right? And I've been doing the trainings for years right now, and we've been trained many teams or many corporate trainings, corporate teams. We trained on a DevOps. So hope I'll be able to help you as well, team, to understand what is DevOps, and you will be able to get a good picture on this course, why or how DevOps can be implemented. The basic part, as we can go ahead again, that is the basic part created. Now I hope so we can continue with our session right now, team. So we will look into our quick agenda, maybe or we will try to understand today. It is just about the theory part mostly. We'll try to understand what is DevOps and why DevOps is required, right? So all these things we'll try to understand, and after that we'll jump onto a little practical mode and what are the tools and technologies that we will be covering in this course, right? We will be discussing about all those things, and then we will jump on to whatever is possible today. That's how we're going to do it. Now, this is a quick program or quick agenda for today, team. So we'll try to understand the basic things, right? And then we'll try to move on to the technologies accordingly, what we're going to discuss as part of this course. So with this, just quick introduction, team. Let's get into our session, and then we'll start about, I know that we have a mixed background of people here. So some of you may know things, as I say, like mixed background of people, which means that some of you are experienced, some of you are freshers, maybe kind of stuff, and some of you are developers, some of you are system admins, kind of, mixed bag of people we have it. So what I'll try to do these is that we'll have to bring everybody onto the same page. So what exactly we'll do is that we'll start with a little bit basics first of all to understand the things. So sometimes if you know that what I'm speaking, you already know, please bear with us sometime. So others will be getting onto the same page as you are. So this is just a request from our side. So with this understanding, team, so as I said, like I'll be starting with the basics. So we can continue with our basics first of all, and then we'll try to understand why DevOps is required accordingly. Okay, so let's look into this one, team. And your questions, team, to be specific again, we will take all of your questions, but all the questions will be answered at the end of the session. We'll spend some time at the Q&A at the end of the session every day. So you can ask your question at the end of the day, and then please, everybody will be in a mute mode. So please listen to the lecture or whatever it may be. We'll try to do it, the rest of things accordingly. Okay. So with this understanding, team, let's get into our introduction part today. What is DevOps and why DevOps? So let's start with the basic definitions, team, a basic understanding of this one. We'll look into it. A very basic, I'll try to discuss, team. As you're looking at the presentation right now, so we will try to understand a few terms before we get into the things. The few basic terms, team, which is nothing but your servers and applications, we call it. Now the server is something, team, we always use it, right? Everybody know, I believe, what is a server. A server is nothing but a computer which process something always, right? And then which works on a model called as a request and response model always. So you would install some applications on a server, and you can send a request into the server and you get a response back. For example, let's say that a google.com is an application which is hosted on a server within the Google data center. You would always send a request using your browser as a client, and you send a request to the Google server, and Google responds back with its application, whatever you requested for. Now this is called as a server, team. You always send a request into a server where some applications are hosted, and you would get a response back from that accordingly if you're able to reach out. Now that is a basic term, team, that you need to understand, because we deal with many servers every day in your organizations if you're already working, correct? So this is the basic term, team, that everybody need to have an idea. So, and apart from that, we try to understand about an applications. Now what are these applications? Basically that we are trying to host it on some servers, right? Why? Let's say that a google.com is an application, I'm calling it. It is kind of an application called as web application, or some purpose it is solving for you. Now if you think about the type of applications, team, basically we do have various types of applications. We do have various types of applications. We call it as a standalone applications, right? Now these applications are normally the desktop applications team, or we also call them as desktop application. They stand alone always, which means that only a single user can access that particular application. And those who are in front of the system, only that person can access that particular application. There are some limitations for this standalone applications always, right? Like examples are, VLC media player or a CalC application that you do it, calculator application, or let's say that MS Office that you do it on your system. These are all called as standalone applications that we normally use it in day-to-day activities, right? Now that is one thing, team. And the second type of applications are nothing but your web applications, the applications that can be hosted on a server, right? When you host it on a server, like we could send a request into a server like a machine again, right? Which means that n number of people can access these applications, like you access google.com, or n number of people access google.com at the same time. Like n number of people can access the same application, and n number of, we can access it from wherever you are, the geographic location, right? Now those are the type of applications we call team web applications basically, which can be accessed over the web or internet we call it, or a network, whatever you do it. Now this is type of applications team that we work on every day today, or you work on every day today basically. Like the example I said, like DevOpsUniversity.org is a website or a web application we call it, or let's say that any simple website that you access is called as a web application always. Now in order to make these things available team for end users basically, as I said, like we use some server to host this application. Like you have a computer, right? Just take an example, then you have a computer and then you have a movie file with you. In order to play a movie, you need to have a VLC media player, any kind of a player that is required to play a movie. Similar to that one team, we have a computer again. I have my application. If I want to make this application available, or if I want to run this application, I need some runtime environment. Now that thing we call it as a web server. In order to run your web applications on a particular computer or a server, we use something called as web server, and we host our application within a web server. Now from you hosted, then we can access that application over the internet or over the network, you can call it. Now this is simple type of a web applications you call it in. A simple websites, right? Like DevOpsUniversity.org is a simple website. Whether you access it or whether I access it, we will see the same content. But when you go for a next level of applications team, when you go for a next level of applications, we call them as enterprise applications. Now these are similar to your web applications itself team. These are also can be accessed from over the web or over the internet. N number of people can access them, and wherever you are in the geographic location, you can access them as well. But what exactly is the difference between a web application and the enterprise application team is that enterprise applications have rich business logic in it, which means that they provide something called as security, mainly that they provide a security and the messaging services, and they also provide or possess something called as a high availability in them. Means that these type of applications are highly available always, 24/7. Whenever you try to access them, they are always available for you, to ensure that to serve you basically, or to whatever the services you needed, you get it done based using these enterprise applications. For example, like Amazon is an e-commerce website, you can access it anytime. Now the example team, the security is that you need to log in to purchase some items on the website, that is by default provides the security for you, right? So once you log into your account, you can see your content, your orders, whatever it may be. That is called as security. Each user level security will be provided by the enterprise applications. Along with that, it also does the messaging, means whenever you order something, it also sends a notification to your mail or maybe a mobile message. These are all called as messaging services, which are used by your applications, which are not done by the general websites. General, when I reach google.com never send me a message saying that thank you for visiting Google, right? It's not going to do it. There are simple website and there are enterprise applications, we call it. Enterprise applications provide some set of things accordingly, right? Now this is what it is team. In order to make these features available, I mean we can go for a web server definitely, but there are some limitations on the web servers which we use it. Now we use something called as application servers to host these type of applications, where application servers will provide the features such as security, messaging, integrations. There are many things which are provided by your application servers according. Just like you have a 4K movie, to play a 4K movie you need a good player. Like if you want to play a normal movie, you can have a normal player basically. Like that is a comparison that you can do it simply so that you could understand why a normal some kind of movie files are not supported by the basic players, right? Because they have rich content in it that should be visible or showed on only on a rich player basically. That's how you can understand about it, right? Now this is type of applications team that we're discussing. Why are we discussing about these applications again team? Because we are working in a software field, right? We are developing some applications like this. These are all called as softwares basically. Whatever the application that you're doing or developing are all known as softwares. So with this basic understanding team, let's move on to a definition which is called as your software engineering, right? Now what exactly is software engineering team? I know we are all software engineers. We are trying to be a software engineer, correct? Now if you try to understand a software engineering definition team here, so it says that it is a systematic and disciplined approach to the development, operation and maintenance of a software. So whenever you're developing a software team, whenever you think about using an applications, it is being developed by somebody and it is made available for you. That is called as operating. You are operating the software to ensure that you're able to use the features of that application. Now, whenever you have some issue with that particular application, you would report the issue back to the, the provider who is giving you that software so that they will do a maintenance for it and support. Maintenance is nothing but a support for you wherever you have it issues. Now that is called a team. The software engineering tells about this life cycle basically, which is called as development and operation and the maintenance of a software together, right? Now simply team, if you try to understand the goal of a software engineering, it is to deliver an efficient and reliable software product to the client or to the end user or to the market, whatever you do it, whatever the business you do it, according to that one we do it. Now this is the simplest definition team that we can understand about a software engineering. Now with this understanding team, but we over the years again we are trying to develop these softwares. In order to make these things possible, we approached or we designed a process. Now that process is called as your software development lifecycle process, right? Software development lifecycle. I hope you heard about this one team, everybody, but I'm just quickly recapping everything or refreshing your minds maybe. Think about it. The software development lifecycle team, it gives you or it takes it involves in a task basically involved in planning your software creation or creating your software and testing your software and delivering it to the end user or market, and finally you do a maintenance for it also, right? It defines the process what you need to follow in order to make these things happen accordingly, right? Now here team, we are talking about something called as SDLC process, right? SDLC process we are talking now. This SDLC process also aims to produce a high quality software team. The end goal is that we always have to provide or produce a high quality software and deliver it to the market. Now this is the goal team. The end goal team, you always try to understand that we are trying to develop some software. We are trying to ensure that it is working as expected, and if it is delivered to the end user, then you try to maintain that. This is the end goal of every software or every software company. Some or the other way, they keep on developing some softwares, adding new features. What are you doing it? Now this is the basic process team or basic mindset that you need to have it. We are working towards some project which is designing a product, kind of a software product basically, and then we are trying to develop it, operate it, and test it and maintain it accordingly. Now if you try to understand these steps team, so over the years how are we able to deliver these products or how are we developing these products basically? Let's try to understand team. We call it as evolution of IT. So when I say evolution of IT team, the first SDLC model that we used to create a software is that we call it as waterfall model. Now I hope everybody know about this again. A waterfall model team, it is that it is about SDLC process. Again, when we talk about SDLC process, it's the process from the requirement gathering till the delivery of the product and maintenance of the product, of course. Now it says that what are the various steps involved in it are nothing but a new phase in the development process begins only if the previous phase is complete. Means it is a dependent process team. If until I finish my requirement gathering, I cannot proceed with my analysis. Until I complete my analysis, I cannot proceed with my design. Now this way of the development team, this way of the development, what is the issue with this way of development team? It is that it is going to take our challenges, we call it, with this type of a model is called as it is going to take very much time or time to market is very high, which means that team again of course you're doing nowadays, right? Whenever you order something on Amazon or eBay, whatever it may be, you expect an immediate delivery, right? Means that you expect the delivery to be very much faster. But here also we are developing a software, or we are expecting this delivery of the software to be delivered to the end user faster way. But with this model team, we take at least 6 months to 1 year sometimes to deliver a software product. Now that is being a very huge time that is not acceptable, or that is not accepted by the client. We need to overcome this problem, right? That is where we moved on next one. But let's look at other problems also with this waterfall, which is no client interaction, which means that once after the requirement gathering is completed, we never go back and check with client again. We never have regular interaction with the client until we deliver the product. So client has done with his job, so we will do our job for 6 months and then we go on back, give it, no client interaction in between. Now the other thing is that called as requirements are rigid, means we cannot accommodate dynamic requirements. Let's say that a client has given a requirement to you, right? After a week he came and say that, okay, we freeze the requirement whatever is given by the client basically, or whoever it is, right? Once we freeze the requirement here, then we started developing it. We went on to the design phase and implementation phase. We are working on the requirement that is given by the client. Now all of a sudden client comes and tells you that, hey, I want to change something in this requirement which I given to you. Now we say that no, it is not possible. Let me finish the whole product. Let me finish all the product. Means that, let's say that a client asked you to paint a wall in red color, right? That's what he asked you. Now you started working on it, you painted half red color. Then all of a sudden he came to you and said that, okay, hey, I don't want red color now, I want it to be green. Now you say that no, it is not possible. Let me finish the entire wall with red color first of all, then I'll come back to you. You can give me the requirement again, then we'll start with green color again on that wall. Now that is a process team that we used to have it with waterfall. This is this way that we are leading to an unhappy client basically, or unhappy customer you call it. Now this is having the challenges team. We need to overcome these problems basically with this model, right? So let's try to understand about more on the evolution of IT at this phase itself. Now we discussed about something called as development phase. That's good. We are developing a product. That's good. That how we used to maintain, or what kind of an application architecture we used to use it, which was impacting the delivery part, right? We say that we used this one waterfall model with developing a product. Assume that we develop the product also, but once after we develop the product, how we are delivering it, what kind of architecture was used, how it was impacting your deliveries time also, that we need to understand it. There we talk about something called as a monolithic architecture. A monolithic architecture is also known as your tightly coupled architecture. When we say tightly coupled architecture team, which means that all the components of your application are bundled into a single a single bundle, and you deploy it into a single server maybe. Now when I say that one team again, let me be a little bit clear on that. So let me do this one. Let's say that team, I have a server now where I want to host my application. Let's say that my application is here. Now I'm saying that team, all the application components are deployed together. Let's say that my application needs to talk to a database. That means that database also resides on the same server. So that these tightly coupled architecture means that the dependencies of your applications are tightly coupled with your application code, and they cannot be separated out. Like it has to talk to the database also resides on the same server here. Now that is the problem team here. Let's say that there is a machine with the operating system, and then you try to install your application database component, the other components which are required by your application. Everything is resided on a single server, right? I call this as a server team, server or a machine you can call about it. Now within this one, this is called as your monolithic architecture. Okay, monolithic architecture, or it is also called as a tightly coupled architecture, right? This is also known as a tightly coupled architecture, right? Now this is what it is team. This is the problem. Now what happens with this kind of architecture team, if you try to understand, when you have multiple things bundled together, the product becomes heavy, which means that it is a heavier component. The heavier components are always hard to deploy or hard to install, and it is even hard to move out also. It's one place to another place. So this is not so easy task for us to do it accordingly. Now this is the problem that we have it with monolithic architecture. That's what we call it. Now this is what it is team. And then when you talk about the server component again, what type of a server we used to use is some team which called as a physical server. A physical server is that team which you can touch and feel it like your laptop. A laptop can be called as a physical server for you, right? A physical system, we call it. Now we used to install our application directly on a physical machine, like we take some hardware and we install some operating system there, right? We take some hardware and we install some operating system. Then we host our application. Let's say that this box, I'm calling it as physical server, right? So let's say that physical, right, server, I call it. Now within this one team, I have means the capacity of this box team, consider that 64 CPUs maybe, and then let's say that 100 GB RAM, right? And let's say that you have 10 terabytes of disk. Now this is how team, the physical servers will have always a huge capacity there, a huge capacity that you can think about it, right? Now this is where team, we simply take a operating system installed on this physical bare metal or hardware directly. Then we host our application here. Let's say that in order to host my application team, let's say this is a Java based application, I install Java. Now in order to run my web applications, I need web servers, such as Tomcat is a web server, I can use it. Now we have this Tomcat web server and we just install it accordingly, right? Now considering this is application stack team for me, now this complete application stack may not use all the resources of my system, right? Let's say that there are 64 CPUs available for me, but to run a simple application team, I would use only 4 CPU, maybe maximum. The rest of the 60 CPUs are wasted. You may say that I could install another application which is going to serve it, right? But it is that team at the enterprise level, we never deploy two different projects have the same server, so two different applications will run on the same server. That is not a recommended architecture for deploying your applications. We never use that. A single server is always dedicated for a single project, always. Whether you use that machine up to the capacity or not, it doesn't matter for it. You have to give a dedicated machine for every project accordingly. That is the recommended approach we followed in the enterprise level always. Now this is what is called as a physical server team. This is what is called as a physical servers, we used to use it. So at the evolution of IT team, we followed waterfall, which is taking a longer time. We followed monolithic architecture, which is also impacting the delivery of my application. We have physical servers, which is also having a problem of wasting enough resource or many resources, which is costing to the company. There is no outcomes coming out. Now, finally, team, you have something called as your own data center. Means whenever I'm purchasing a server or a hardware, I need a place where I can keep that servers, like your building or a server room, you call it. There is a building that you procure it or you build it, and within which you are going to put your hardware and then enable the networking to communicate with the server, maintain the internet connections, maintain the backup for your internet connections, maintain the power and power backups, right? Maintain the cooling temperature for your servers. There is a lot of maintenance that you need to take care of within your data center accordingly, right? Now that place is called as data center team, where you host your servers or where you keep your hardware. That place is called as your data center. Now this is the first evolution of IT team. This is the first evolution of IT, basically we have it. Now within which we are seeing that everything is a little bit problematic, which is costing a lot, which is taking time to delivery, right? So there is a huge maintenance is involved in this process. So we are, of course, we cross this stage. Basically we used to have this one, but we crossed this stage and then we were trying to improvise the things on our side. So we started moving to the next phase of evolution of IT team. The next phase of evolution of IT, we changed the Sdlc model, right? The first Sdlc model is nothing but your waterfall model. Now the second software development lifecycle model that we started using was Agile. Now I hope you're all working on Agile model team. Most of you are working on Agile model, I believe, right? What exactly is this Agile? How exactly it is improved? It is improved our development process, right? How exactly we're developing right now when compared to the waterfall. Now this Agile process team involves something called as a Scrum team, or we call it as a Scrum team or Agile team, we call it. This Agile team is consisting of a few roles and responsibilities team, out of which one thing is called as your product owner, right? A product owner is responsible for interacting with the end client, and he will get the requirement from the client and he will start writing something called as a user story. A user story is nothing but a task or a feature that you want to develop for a software team. Bits and pieces of your software, basically think about it. Instead of delivering or instead of gathering the whole requirement at once, we with the regular intervals, we call it that regular interval, we call it as sprint iteration here. Within Agile we follow something called as sprint iteration model, right? Iterative model we call it. Now with this iterative model team, we keep a A shorter goal is like, let's say that we take a 2 weeks time and we'll try to deliver something, right? That is what is a shorter goal, we call it. So we take it 2 weeks time, that is called as sprint iteration. You could have 1 week to 1 month also, but usually we take it as a 2 weeks as a sprint iteration time. That is the goal that you can keep it. Now within this goal, the client or the product owner gathers some requirement and he prioritizes the requirement. He prioritizes something which is required by the client immediately. He will write a user story for it. So the user story is nothing but a task that need to be developed, something, a product need to be developed, a software need to be developed with that user story. Now there is a team called as Agile team who picks up these user stories with this whenever they call as sprint planning. We start with the sprint. The start of the sprint, we had a sprint planning. They will all pick up the user stories what they can work on. Once they pick up the stories, they will start working on it. Once the work is being in the progress, there is a guy called as Scrum Master. He will be like a mentor for this team who are developing or who are working on these user stories. He will continuously watch over and he will keep a meeting called as a daily stand-up meeting, right? You see that team, there is a daily stand-up meeting, we call it. So the daily stand-up meeting, we ask regularly 3 questions everybody in the team, which are nothing but what did you do yesterday, what are you going to do today, and are there any impediments that while you're working on your work, right? Impediments in the sense, are there any troubles that implementing your task accordingly? Now these are the regular questions team that everybody have to attend, or everybody have to attend this daily stand-up call. They have to answer these 3 questions so that the guy called as Scrum Master keeps track of the work, and if there are any problems, he will keep on informing the client for the better communication with the client always. This guy will be doing like this, right? Now let's say that within the sprint we aimed at something and we developed something. Now at the end of the sprint, we simply demo to the client basically directly. So if the demo are liked by the client, then we will move on to the next environment for deployment for various other things according. Now this is a regular process team. For every 2 weeks, we take some requirement, we develop something and we show to the client. If he likes it, we'll do it. If he's not liking it, we're gonna redesign that as per the client requirement again, which means that team here, we have a regular interactions with the client first of all, which was not in the waterfall model. Now there is a dynamic requirement gathering or dynamic thing which is given by the client. We are accepting the dynamic request, which is also was not there in the waterfall. We accommodated here. Now the final thing is that team here, when you work with the waterfall, basically we gathered all the requirements, maybe hundreds of requirements, and we are taking them as one challenge and we're delivering after 6 months. But here within this model, we are delivering every 2 weeks one or the other feature, so the client is getting happy here. Now that is the advantage team that you get it with the agile model, which is also known as iterative model basically. So with which we team, with agile model basically we achieved very much speed in the development process. So every 2 weeks we are developing one or the other feature, we are showing the client is happy, right? So we achieved something called as a speed in the development process team, right? Speed in the development process, that is good. So we are able to develop the product faster, which means that we could deliver also faster, right? That is what it is. So but I'm talking about only the development as process team. Development has been speed up, but not about the operation or this one delivery part. We'll still hold on that one for a minute. So let's try to understand various other aspects of this IT evolution, right? Now here team, we saw that agile is helped in developing the product much faster. That's very fantastic, good. Now let's say that with that model, keep that aside right now. We are also discussing about application architecture need to be simplified, because monolithic architecture was a heavier one, which is which is kind of a bottleneck for us to deliver our product into the master production environment, we call it, right? This is where team we try to look for another solution, which we went on to NTR architecture or a 3-tier architecture, we call it. Now what exactly is 3-tier architecture team, if you try to understand, right? So we had something called as monolithic architecture team, which means that all the components of your application were installed on a single server. But here team, when we talk about NTR architecture, we segregated, or we divided, we decoupled the architecture, or we decoupled the components completely, and we hosted them on a separate servers altogether. Let's say that there are 3 things here team right now, try to understand, right? That we are taking different servers altogether, different machines, you can think about like different laptops, you can think about it. Now let's say that I'm calling or I'm hosting an application here. Let's say that this is my bank application or something. Let's say that your internet banking that you use it normally. We say that this is my bank application which I hosted here. Now this is where team consider that this is a machine or a server can be where it can be hosted. Now, if my application wants to talk to a database, I would install the database on a different server altogether, right? So let's say that this is my database, right? Now, similarly, team, if I want to send a request into this one, I need not to sit here. I can send a request from my, the browser. Now, the browser is being a client here, right? So browser is a client. Now, likewise, team, we divided or we decoupled our architecture to access our application separately, host it somewhere separately, and if it requires the data, database is separate, hosted completely, right? Now you decoupled architecture team here completely. Let's say that I sent a request to my bank application. It responded me with a login page. Now I entered my credentials. It is need to authenticate it. We know that the server does not store any data here. So database or your server contacts with the database to validate your credentials. Now this is how team we have different layers. Different components are maintained at different layers. Now this is where team we called as this can be called as your client here, where the client access your UI. Now where you hosted your application team, which is called as middle tier, right? And where you hosted your database is called as backend tier simply. Now likewise team we segregated into different tiers or different things entirely. Now this is where we talk about something called as this is called as 3-tier architecture team. I hope you understand about it already. Maybe let's look at this is what it is. Now it is also known as your n-tier architecture. This is also can be called as n-tier architecture. A 3-tier architecture can be called as your n-tier architecture also without any question. Now this is what it is team, simple thing we call it. So in a technical terminology team, if you talk about it, the 3-tier architecture is like this, a presentation layer we call it. A presentation layer is nothing but the UI that you see it, right? So there is something called as uh, application layer, right? We call it as business layer here, right? Business layer we call it, where you process your business transaction, like whenever you perform some submit action, whatever it may be, it will perform something to connect to the database, everything. Now this is called as business layer team. And finally, you have something called as data layer. So data layer is nothing but your database always, right? This is the technical terminology team. If you think in the developer's perspective, this is called as a 3-tier architecture. There are 3 different tiers, like presentation is UI, and the business layer is that where you process the business logic to perform an action, right? And whenever you save some data, the data layer comes into the picture. If your application is storing some data into the database, that is called as your data layer. This is in the perspective of developers view team. A developer who develops an application, he looks it into this direction. But as an end user, we can see that we are a client, right? As an end user, we see it as a client tier where I access my UI, and then whenever I send a request, that goes to the server that is hosted on the middle tier, then the data goes on the backend tier accordingly. This is general team. This is how we splitted it. Now what is the advantage of being this one team? Since we split a team, everything becomes a minimal weight here, a lighter weight than your monolithic product. So it is easy for us to troubleshoot the issues. It is easy for us to deploy it, a lighter weight component always. Install something lighter weight is always easy for us. Now that is the advantages you get it. Along with that, we also segregated into various things, so troubleshoot becomes easier. Now various things are managed by various people, whereas advantages we get it with this architecture. Now that is what we did it team, that is what we did it, right? Now team, one more thing here. Of course, we moved or we improvised something from monolithic to n-tier architecture to make our life easier. Now we also converted our physical servers into virtual servers team. We also converted our physical servers into virtual servers. The virtual servers are nothing but, I hope you guys know it, but let me quickly tell you that. So what exactly is virtualization team is that we convert, right? The same physical server team, try to understand that we take the same physical server here. So we take the same physical server. Okay, let's say that there is same capacity which I'm taking it, whatever the capacity of your physical server that you have it. But instead of installing an operating system directly team, instead of installing an operating system directly, we install something called as hypervisor. Now this hypervisor team provides something called as a hardware level virtualization, as we call it as hardware level virtualization, right? What do you mean by hardware level virtualization again? Which means that it is going to let me create a virtual machine team, which is also known as a software computer. Now within this physical machine team, we convert this single physical machine into multiple virtual servers, which will act as an independent computer. Like you have multiple laptops with you, every laptop is independent of it, right? Every laptop has its own operating system, its own networking utilities, its own softwares, its own applications, everything like that. Similar to this one team, every virtual machine here is going to act as similar way, right? It has its own operating system completely. It can have its own softwares installed in it. It can have its own applications deployed in it, right? Here I have Java based applications. I did it. Here I can have a Windows operating system, right? And I can host my .NET based application here, right? It's all different VMs team. This is called as a virtual machine. Everything is known as a virtual machine here in simple words. Now it is simple thing that team, we are converting or we are virtualizing our hardware. We are virtualizing our hardware into a multiple virtual computers, right? They will act as this one. So every computer here is an independent computer. It has its own set of properties and its own network settings, everything accordingly, right? Here I can have another Red Hat system maybe, right? And I can install my Python based application here. So you could have every machine have a different type of application can run. Now we overcome the problem of resource utilization team, because whenever you do something called as hardware level virtualization, means whenever I create a virtual machine team, a virtual machine is always created on the basis of your hardware resources. Mean to say that whenever I create a virtual machine, I need to allocate some resources here. Let's say that I'll go with 4 CPU for this machine, like, and let's say that 10 GB RAM for this particular machine, right? Out of the capacity team, the hardware has the capacity, but we are splitting the hardware resources into a smaller groups, and we are running our systems accordingly, right? Let's say that here I can go for 100 GB disk. Now this is what it is team, you can understand about it. This is how you can understand about it here. So every virtual machine have its own capacity right now, a minimal resource, so that we could split the same hardware resources into multiple virtual machines, so that we could utilize the resources much effectively, much effectively. So which reduces a lot of cost for your organization, obviously. So because we are splitting the same hardware into multiple systems, which is letting me host multiple applications in the same way, right? Now this is the advantage team, and viewing the virtual machines are very much easy to create it compared to the physical servers, right? Compared to which is easy to create it, they are all can be maintained by software defined networking and something. So there are many advantages that you gain with the virtualization accordingly. Now this was a revolutionary thing team. Over the night everything has changed in the industry of software, which helped us. Or nowadays also we're using these virtual machines only. Everywhere is a virtual machine. Every organization uses virtual machines for hosting their applications accordingly. Now this is how team called as virtualization. So we improvised a lot on the virtualization from physical server to virtual servers. And we also started using the hosted data centers team, which means that I ran out of space team on in my home. Let's say that I was living in a single BHK or 1 BHK house. So I had a family with 1 kid. Now we are grown and we have 3 kids right now. So it is 1 BHK house is not enough for me, right? I need to shift into somewhere, right? It is my own house. If I want to build my own house somewhere, right, it is going to cost me a lot. Instead I can go and rent some house and can shift into a 3 BHK house, right? Now that is what is the simplest thing that you can do it instead of spending a lot of money there. Now here team, similar to that, organizations whenever they ran out of space within the data centers where they cannot host many more servers again, instead of purchasing a new servers, or instead of building a separate building for putting the new hardware there, they go to a third party company and they just rent out some servers, right? They host their applications. The end goal is that you need to host your application. That's it. That is what all we talk about it team. That is what all we talk about here. At the end of the day, I need a server where I can host my application, whether it is my own server or it can be a rented server. I don't worry about it. Now the hosted data center is something apart. It is not your own data center, but you host your application on a third party data center where you rent some server and host your data center accordingly. That is what it is team. Just for a comparison quickly, so your data center is like your kitchen, right, where you have to put everything and you need to cook yourself and eat it. That is what you're. But hosted data center is like your hotel, right, where you can just go and order something and eat out and come out. right? That is what you do. That is a quick comparison that we can do it to understand about a data center and a hosted data center accordingly. Now this is what it is, team, which is very good. Now we discussed about some challenges on the waterfall, right? And we, in order to overcome, we discussed something called as agile. With agile team, I'm stressing something again. With agile, we achieve the development speed, a speed in the development. So we are able to develop the product much faster, right? We made sure that our application architecture also a little bit changed, which is helping us to move the product a little faster, right? And virtual servers hosting are making a lot of easier for to host my application and then something. Now here team, of course we are doing this one, but what are the challenges? With agile team, we discussed about everything is positive so far. Development speed, NTR architecture, virtual servers, everything is positive that we discussed. But why are we moving to the next model, which is, you know it right now, which is nothing but your DevOps, right? The next thing is DevOps team. But before we understand about DevOps, let's try to understand what are the challenges that we have it with agile, so that it will help us understand why we need to go for the DevOps, right? So let's moving this one team here. Moving to this one, basically, we talk about some challenges about your agile here. So this is where we talk about something called as infrastructure readiness team. The infrastructure readiness is a big question here. Infrastructure readiness is a big question here. What do you mean by infrastructure readiness here? Now trying to understand team with agile, as I told, like the development speed is increased, which means that team, there is a development team called as agile team, part of QA, QA teams and our development teams are part of these teams basically. Now there is a product owner who is part of this one. So they have a daily call called a stand-up call. They will discuss everything every day, right? The client gives the new requirement, the developers are working on the new requirement. They keep on developing it. But does it mean that is it product delivered to the end user immediately, right? Because team, there are separate teams or where you host this application once the development is completed, once your source code is available, right? Where we host this application is called as various environments like QA environment, right? You have a pre-prod environment, and then finally the production environment, right? Production environment is where team you host your application basically. But who creates this environment? Nothing but a server again, where this application can be run, right? Production environment is a set of servers team, a set of servers where you deploy your application basically, right? As I told, like if I want to run my application, I need an environment, a runtime environment, which is created first, then I can deploy my application there. Now the question is that team, with every 2 weeks you're developing a new features, right? But are you increasing the capacity of your infrastructure also? For example team, let's say that you have an iPhone 6 in your hand. Now the latest software is called as iOS 13, because they keep on adding the features to the iOS after they released iPhone 6 also, they keep on adding it. Now you still have your iPhone 6, they keep on moving to the iOS 13 right now, right? If I deploy my iOS 13 on iPhone 6, what happens to it? Because team, there are many features which are not supported by the hardware, right? When I say infrastructure team here, infrastructure is nothing but your hardware capacity or resources you have it. The hardware of your iPhone 6 does not support the features which are there in iOS 13. Now what you need to do it, you need to upgrade to the iOS 11, iPhone 11, you need to do it. Then iPhone 11 has a new hardware with more capacity and everything, which supports all the functionalities of your iOS 13. Now that is what is need to be done team here. Let's say that within 2 weeks we developed many features, and when we want to deliver it to the end environment, which is production, is your production infrastructure ready to host these new features accordingly? Now that is a question team, because you used a new features, everything is there, but your infrastructure may not be ready, that need to be upgraded also according. But you are informing at the time of deployment to the operations team that this need to be upgraded. Now the operation team simply says that it cannot be done overnight. I need 2 weeks time. I need 2 weeks time to upgrade my production environment. Then you can deploy your feature. Which means that team, infrastructure readiness is a bottleneck here to deliver your application. Though we are able to develop the product speed, we are lagging in the delivery part still. We are having some issues in the delivery part because of infrastructure issues, or it can be any other issues also team. That is one of the issue we call it. Infrastructure readiness is one of the issue which is lagging or which is delaying your delivery to the environments. That is what we call it, because of the lack of communication team. I call this lack of communication between the development teams and the operation teams or maintenance teams, we call it. That is the first problem that we have it. Now the second thing called as scalability. Scalability is something team how quickly I can scale in my environment. Let's say that Amazon announced a big billion day. Amazon announced a big billion day. Usual traffic they get is 1,000 requests every day, but on a big billion day, they're getting 10,000 requests. Now, in order to process this 10,000 request team, or let's say that in order to process the 1,000 requests, they have 10 servers in the production. But when you want to process 10,000 requests, team, they have to increase the capacity of the production to 100 servers. Now, team, this is being an on-demand business. Basically, I want to have these servers for next 5 days. After 5 days, I want to destroy them again. Now, the question here is that, team, how quickly I can scale out my infrastructure, right? How quickly I can create another 90 servers for tomorrow, and then I would destroy them again after the 5 days period of your big billion day. Now, this is on-demand scaling, team, we are expecting nowadays, on-demand business. I don't want to use it, but how quickly I can do this? Scalability is possible, team, but it is hard one. We need a more sophisticated infrastructure where we can do with a single command, I can have my infrastructure ready. Now, that is what we are looking for it. That is scalability is possible, but it is a hard one. That is still a challenge we have it. Now, the quality of the product, team, the quality of the product is that the quality of the product in the sense the team, let's say that your client has given a strict deadline that you have to deliver the product this Saturday, right? This Saturday is what you need to deliver it, but you're still started with the development right now and you're still developing a product or a feature. Now you completed the development on Thursday, the delivery is on Friday, or let's say that Saturday, right? You have only one day to finish the entire testing of your application. Now you may not be doing thoroughly, team. You may do the entire testing. I agree with that, but you may not do a thorough testing. Not all types of testing can be performed within a single day. Now that is where, let's say that client has given a deadline, so that deploy into the production. So without testing your product, sometimes, I'm not saying that every time, team, not everybody does it. There are some challenges here. There are some chances that you would do this. A quality of the product may be missing because of the strict deadlines of your, given by the client sometimes to deliver the product, right? That's how you can understand about the quality of the product, maybe reducing it. So without testing, you delivered the production. In the production, it is failed, which means that client had some issue. That means that quality of the product is reduced. That is what we call it as quality of the product, team. Now, the last thing here to call as a limited release windows and releases may fail or slip, which means that again, this is another challenge. Now, team, whenever I want to go ahead and deploy into my production, I cannot do that because client needs approval, or we need approval from the client side before you deliver your application into a production environment. During a peak business hour, team, the client never allows you to upgrade your application, right? Because that might cause some interruption to the services that you do it. That is where client says that, okay, you have to deploy the application on Saturday midnight, 12 to 6. That is what the window we call it, the client approved window. Within that window itself, we will go and deploy our application. What exactly is the problem here again? Let's say that my feature is ready on Monday itself, but I still have to wait till Saturday to deliver that one. Now the question is that when the feature is ready, why would I have to wait it? Because we need to give it downtime. Now, can I deploy without a downtime for my client? Then client agrees with that. So how do I develop a strategies to ensure that we have to deliver our application as soon as it is ready? Now, this is the limited release windows, team. Right now we have it. We are following a structure of release windows or maintenance windows to deliver our applications. We need to overcome. This is also a challenge that we are looking to overcome some problem. And that is what it is, team, we call it. That is what we call it. There is one more big challenge here is that, which is this one. Works fine in dev and ops problem now. You know that what is this one, team? Most of the team which actually look into this one always gets this problem, especially those who are in the production support. They will hear this regular thing. It is nothing but, team, when you say that you developed an application, we did not directly deliver into the production, but we do deliver in the before that, which is called as your QA environment or a pre-production environment, where we test our application thoroughly. Because, team, let's say that as a doctor, or let's say that we are in the pandemic right now, right? We are in the pandemic COVID, so we are trying to get a vaccine for COVID. I said there are many, pharmacy companies that are trying to develop this vaccine, but whenever they develop this vaccine, team, do they test directly on a person, or they directly test it on a, kind of any other body like rat or something like that, right? You test it on some rat. If it is successful there, then you come and test on a human body. If it is successful, then you deliver it to everybody else, right? Now that is how, team, that is how the product's also being done. Basically, whenever we develop a product, we do not directly deliver it to the end user, but we do test it. we do test it in our own QA environment or lower environments within your organization. You ensure that the product is working fine as expected. You test it thoroughly. That's when you deliver it to the end user. That's where the product will be. Now this is what is team. Let's say that sometimes what happens is that you test it thoroughly in your QA environment. It works absolutely fine. But when you deliver it to the production, it fails. Now this is a regular problem team that everybody gets it. Now what is the reason behind it? Now here team, try to understand the problem is regular. We get it every day for sure. Most of the people use it. Now the question is that how do I resolve it? But before resolving team, first thing we do is we blame each other. Let's say that operation team says that it's a development issue. Developer says that it is working in fine in my laptop. It's your operations problem only. Now this is the blame game starts team first of all before you resolving the issue, which means that at least you fight for a couple of hours, then you sit together and deliver it, or you fix the issue at any point of time. The problem here is that team, why do you blame each other first of all? Because the goal is that you need to deliver it, but instead of that one, we are actually blaming each other. We are wasting some time, at least couple of hours. Then at the end of the day, no matter what that need to be delivered, so we fix it, or developer may be fixing it, or operations may be fixing it. They work together at the end of the day to fix the problem, right? Now this is happening. Basically this is one of the problem, a major problem. We see it very regularly in every organization. Now, how do I resolve these issues also? What are the reasons behind this works in development, not works in production? When you do sometimes like this, what exactly the reasons behind it? We need to address these challenges also, team. That is what we call it. Now, in order to resolve all these things, team, in order to resolve, or in order to not say resolve it, just say that we need to achieve all these goals. Take this as goals basically, and we need to achieve this one, right? Now, that is where, team, we are introducing you to the new one, which is called as your DevOps, right? So DevOps is the model team which help us achieve all those things. Now, if you try to understand team, there are many questions that people do ask. Is it a culture? Is it a job title? Is it a team? Every person has its own, conception team about this DevOps process. Basically, DevOps is not a technology. Basically, DevOps is a simple process with which we are trying to achieve some goals of your software delivery. That's what I call it. Now, if you ask me the question, team, or if you ask me the definition of a DevOps, this is the most definition which I like it always, which is DevOps is a reorg, basically, not a new team to hire. What I mean to say that, team, is that the main goal of the DevOps is that you need to collaborate first of all, which means that, team, earlier we have a development teams, QA teams, and operation teams like middleware teams, database teams, network teams. Everybody is their team. Let's say that the maintenance or production support team, everybody is doing one or the other part of the project. Let's say that there is a project that need to be developed, that need to be delivered or operated, then to be maintained. Now, in order to achieve this end-to-end goal of a software engineering team, there are various teams involved in it. Now, everybody used to work in a silos. Means everybody, the developer may not know the who is operations guy, and operation team may not know who is the developer, but they still do this one, right? That is what it is. Now, that is how it used to happen so far. Now the DevOps says that, team, no, don't do that one. Don't do that one. When you are working towards a single goal, right? When you are working towards a single goal, why can't you work together? That will build a better collaboration, and that will help us deliver the product better to the end user. So we have to collaborate. And that is why, team, we say that it's reorg. Reorg in the sense, you have every team. Your development team is there, middleware team is there, every team is there in your organization. Let's say that you bring everybody into one place and say that you're all a single team. You're all working towards a single project. You're all a single team, work together to achieve the goal. Now, as a teamwork always gives us the best results. So we are trying to form a single team of my DevOps where multiple talents or multiple skills are available within that one. That is where I say that reorg team. So you need to reorg the entire organization structure to keep it into a single team. Now, if you go for a more technical definitions team, try to understand the technical definitions also. That is the first goal of your DevOps. Let's get into the technical definitions also here. DevOps is an agile IT operations delivery required to match the cadence of IT agile development, right? What I mean to say here is that, so here team, when we brought in agile into the development side, we achieved the speed. I said, like, with agile we are able to develop the product with speed, right? That is what happened, but we are still lagging in the delivery part because of the lack of communication between various other teams. Now this is where, team, we see that, okay, let's bring the agile into the operation side also, so that everybody should need to participate in the same daily sprint call, daily stand-up call, so that operation teams also involved here. Now the operation teams also comes to know what is client is requesting, right? Now that is where operation teams understand, okay, this guy is using the new features, for which what are the things which is required on the infrastructure side, right? Now that is where you can have more collaboration, right? And then you can have achieve the goals. So team, try to understand agile or DevOps is not a replacement for your agile. Try to think that DevOps is not a replacement of agile. Basically, like we replaced waterfall with agile, that is altogether different, right? But we are not replacing agile with DevOps. We are extending the agile into operations phase, and that's called as your DevOps. We are not replacing team, we are still following the agile, we still follow the daily sprint, we still follow everything that we're doing it, right? We are extending the agile into operation side from the development area to the operations area. Then extension of agile is known as your DevOps. So that is what all we are telling about it. So we still follow the same agile methodologies, but with extended into the operation side, everybody should be part of the same sprint meetings, same daily stand-ups accordingly, including the operations teams and support teams. Everybody should be part of the single team right now. That is why we say that DevOps is an agile IT operations delivery. We are bringing agile into the operations phase. That's all we're doing it. That is called as your DevOps. Now, when we're talking about DevOps team again, DevOps is the philosophy of unifying development and operations at the culture, practice, and tools level to achieve accelerated and more frequent deployment of changes to the production, right? Now, this is what we're teaching. As I told, like the goal is that you deliver the product to the end user faster, faster, faster. We are talking about faster, faster, faster. That is the goal of DevOps basically. It's not only that, but it is also something, right? DevOps is first a culture. You need to bring in the culture by reorging or re-putting them everything into a single team. That is the first goal of your DevOps, we call it. Culture and collaboration with developers and operations teams. The culture has given a scope of set of practices, right? So DevOps is a revolutionary movement by practitioners for practitioners, we call it in simple words. This is what it is, team. Now, if you talk about the simple goals of your DevOps team, the goals of the development team, if you try to understand splitting right now again, the goals of the development team is to deliver the features into the hands of customer with speed or as quickly as possible, we call it. But so their goal is always speed. The developer's goal is always that speed is what it is. But comes to the goal of an operations team here, they also have to achieve the delivery speed. We need to deliver the product into the production with speed, but at the same time we should not fail, or we need a stability also. After you deliver to the production team, the product is not working, it doesn't make any sense to deliver its speed basically. So we say that we need to deliver the product into the production, at the same time ensure the stability of the product, which means that the product should be absolutely working fine in my production environment. Now that is the goal of your DevOps team, or DevOps team basically we call it. So stability with the speed of delivery, that is the goal of your DevOps actually. That is the main goal, right? The first goal is that bring the culture. Second goal is that achieve the speed and stability accordingly when you deliver your product. With Agile, we developed it speed, we increase the speed of development. With DevOps, we are going to increase the speed of delivery and stability, bringing in at the same time. That is what is called as DevOps team. Time to market is something we're talking about it. We must be speed and we must be stable. No production failures. Of course, team, it cannot be a scenario where we cannot failure. Without failure, you cannot learn the things also always. You can fail, team. I'm not saying that you should not have any failures. You must have failures. Then only you can learn the things accordingly, definitely. So failure it, but do not fail for many times. If you fail it also, team, how quickly you can bounce back is the question. That is where we call this immediate recovery from the failures is required. So we need some kind of lot of automations in place which can help me roll it back quickly. That is what we're looking for with this DevOps. Now, final thing, team, is that there is no wall in DevOps culture. Try to understand, there is no wall in DevOps culture. I'm stressing again, there is no wall in DevOps culture, which means that everybody is equal in a team. Everybody, or there are various skills that may be there. Maybe a developer is there, maybe a QA is there, maybe a middleware engineer is there, maybe a database engineer is there within the same team. Now there are no walls for everybody. Developer can go and look into production environment. A production guy can come and see what is in the development environments. So they have to have no walls in between. They should be able to move flexibly. You should have your mindset team is that you need to do not stick to your area, extend yourself into multiple areas of your project. That is what it is, team. So do not keep your boundaries, open your boundaries and move out and then look out what is happening other side. That is what is something DevOps tells you, team, always. So that is what is called as goals of DevOps basically. Now team, we are talking about speed. With the DevOps, we are talking about speed. Now we understood about what is DevOps basically. With DevOps, we're trying to say that we need to get the speed of delivery and stability. Now, how do I achieve the DevOps team again? Right, so that is what you see it. How are the application architectures required to deliver it speeder, right? And what is the deployment packaging, like virtual servers, what is needed, and a data center team nowadays we call it. You know why we use a cloud team? A cloud is an environment where it will help you to do everything with faster. Means that sitting at your home, you can do everything as service as long as you have internet connection. You could get your entire infrastructure in a matter of minutes. Of course, that help you to get the speed immediately. So that's where we are trying to move on to the cloud environments. A cloud is a data center team again. A cloud is also a data center, but it is managed by somebody and they're offering entire things within a data center as a service for you. No matter what happens, they will take care of maintenance, they will do everything for you, but you get it as a service. You pay for what you use it. It is a pay as you go model that you use it with cloud. So it will be easy for you. You don't need to concentrate on maintenance, you don't need to concentrate on how to purchase and how to maintain. How do I have this entire team set up completely? You don't need to worry about anything. Just concentrate on how do you develop your application, how do you host your application. The rest of the parts are maintained by your service provider. That will make your life easier to make yourself comfortable and then to concentrate more on the work that you're doing it accordingly. Now that is what is cloud team. Cloud enables the speed immediately by providing your entire things as a service, infrastructure or software, whatever you need it, everything as a service, which increases the speed, which increases the efficiencies of your organization immediately. That is what we call it. Now the second thing is that team, as we are talking about speed, cloud is helping us with speed. Now along with that team, we also need to discuss about application architecture need to be changed a little bit. With anti architecture team, we always decoupled architecture. We call this is called as decoupled architecture, which means that we decoupled various components into various servers so that we achieved this one easiness with it. But let's try to achieve a little bit more team. Let's try to achieve a little bit more here by splitting our application into more smaller pieces. Now, what is a microservice team? If you try to understand in simple words, I'm not going to go technical discussions of microservice here, but let's try to understand here about a simple definition of your microservice. So what is a microservice and how does it deployed basically? If you try to understand team, let's say that earlier we decoupled architecture, which is called as 3-tier architecture here. That's what you see it here, very simple. Now when I say that team here, microservices is all about your application components, we call it. Let's say that within this one we deployed our application into a single server called as this one, where my bank application is hosted. We talked about an example of your internet bank, right? Now here team, if you try to understand about it, when you access your internet banking application team, there are various features of your application, we call it. Let's say that there is a login feature. That's what you get it as a default page. Now after this one team, once you log into your application, you see the various services within your internet banking, it's such as your debit card services. Now let's say that credit card services, right? And let's say that there is a loan service that you have it, right? And also you see something called as mutual fund, suggesting various functionalities of your application, basically we call it, right? Now this whole application team, let's say that there is a single server which is hosting all of these application features accordingly. Now consider that team, there are 100 customers or 100 users who are using my internet banking right now, out of which 90 customers or 90 people are using a debit card section where they're trying to perform some transaction on the debit card. 10 customers are using the credit card section, right? That is what they're doing it. Now all of a sudden team, all of a sudden there is a problem with my credit card section, which means that their credit card statement is not visible, which means that only 10 users are impacted there. 10 users are not able to see their credit card statement. That is a problem. The rest of the functionalities are working absolutely fine. Other 90 customers are solved up, but these 10 customers reported the issue to the bank. The bank has rectified the issue. Now whenever they try to redeploy this whole application team, The way they have to do is here is that they have to take down this entire application, which consists of all application features, which means that when I take down this application, there are 90 customers who are accessing debit card. They do not have any issue in accessing it, but they still see the application going down because of some other functionality issue. Now this is a complex architecture team here, means this is a tightly coupled architecture for this one again. Now how do I make this simpler more, right? Now instead of developing this entire application as a single bundle team, entire application modules as a single bundle, so why can't we develop, right? Why can't we develop our application as separate application? Let's say that login is a separate app. Let's say that login app is a separate application itself. It is nowhere dependent on the other things. So here it is, a debit card is a separate application, right? That debit card is a separate app, debit app I'll call it. Let's say credit card app, credit app I'll call it. Let's say that loan app I'll do it. Now let's say that mutual fund app also separately, which means that team, instead of developing the entire features as a single application, I'm developing every piece as a separate application altogether. Now how they communicate internally team, that will be taken care by the developer. They will have to communicate it to act as an end user. As the end user team, he must see all these features again within the application. Though you develop it, that is what it is. The developer will take care of that one team. But here, when I develop it as a separate application, basically, I could deploy them into a different server, right? Let's say that Tomcat is what I'm hosting it here. Now let's say that to this one, I'll go for Nginx, maybe something like that. Now let's say that to host this one, I'll go for let's say that JBoss. There are various technologies team that can be hosted your server to make it available. Let's say that here I'll go for WebLogic something. Now let's say that this also application I developed or I deployed it on the same Tomcat server again. Now since these are all the applications team, these are all the different smaller applications, the smaller pieces basically. Now every piece here is called as a microservice team. Try to understand, every piece here is called as a microservice. That is the advantage that you get it. Yeah, the more lighter weight you are right now. Let's say that this is a lighter weight team because this is a very less code right now. Instead of developing 10,000 line code, now split it into 10 different applications, which is that 10 different applications have it, 10 each 1,000 line code. Now it is easy for me to troubleshoot the issues. Now they have become the lighter weight. When you are lightweight team, it is easy to ship it in a sense we can easily deploy it. Whenever you're lightweight, basically it is easy to run also. That is where the advantages that you gain it, right? Now this is how team we are converting our application architecture into a microservices architecture, which is a more flexible one, so that you could deploy a number of services here. The advantage here is big, that if you understood right now, if I credit card is problem, now I can simply deploy only this piece, right? I do not need to impact other application components here, whereas which means that the 90 customers will never see a downtime, but whereas the 10 customers which are having issue with the credit card, they will see a downtime, they will be okay with that. Which means that the end of the day, you're trying to increase the client experience here with microservices, which helps us maintain the application easily, right? And then give no downtime applications to the end user, so that end user always happy with you already, right? Now that is a concept team called as microservice. That is a concept of microservice basically in simple words. So it is very easy for us to understand, or it is very easy for us to deploy like this. Of course, they have their own complexities when you're developing it. They will be taken care by the developer. So understand that every piece is hosted on a different server, so that you could maintain that as a separate piece. At the back end, you will see as a separate pieces, but in the front end, the end user still see the same login page. Once he log in, he still see the same debit card, credit card, everything within his application login. He will be able to see the same thing, but at the back end, they're all maintained separately. That is what is the thing. That is what is something called as a microservice architecture that we call it, right? Now why we are doing again lighter weight, because we are talking about the speed with the DevOps already. So microservices help us move your application with speed into the production. That is what is the goal again. They may also help you with the stability team. That is what you can understand it. That is what is simply we call it as a microservice architecture that we are trying to move it. With DevOps, we now into the cloud. Cloud helped me to speed and efficient way. Efficiency has been increased. Microservice also helping me to make it lighter weight. The lighter weight becomes more faster deliveries. That's what. Now there is one more thing here, team, which is also known as containers. Of course, containers are a big buzzword in the market right now. Most of you may know it, or I don't know, team, how many of you know here. But try to understand, containers are a buzzword in the market. With DevOps, With DevOps, the major technologies within the DevOps people discuss about is called as containers. Containers are a way to host your application team. Containers are a ways to host your application. Now let me talk about what exactly is container team so you would understand it, right? Now let's say that team, we had a simple problem. We had some problem called as this one, right? We'll talk about this problem which will especially resolved by the containers working fine in development and not working in production basically. Now this was the problem team which we had it. Let's try to understand how do you address this with this containers technology that we have it in the market right now. So try to understand team here, which means that uh, as I told team, when you develop an application, let's say that this is called as my app, whatever I developed it here. When I develop this application team, I do not directly deliver it into the production, but whereas where I have various environments like development, QA, and let's say that pre-production, and then finally the production, right? This is what you have it. Let's say that team here, whenever I'm developing it, this is what you do it: development and QA environment. And let's say that these are all the servers team, saying that there are different environments are nothing but different servers where you host your application, pre-prod I'll call it. Now finally team, the goal is that you need to deliver it to the production, which means that team, let's say whenever you hit a google.com, the request goes to a server within the Google data center where the google.com application is running, right? Now that environment team, that server where you host your application, where end user sends a request, is called as production environment. The end goal is that we need to deliver it to the production environment team. Now in order to deploy this application team into a server, let's say that if I want to deploy this application into a server basically, right, there are some dependencies team, means this machine or this hardware should have at least a minimum operating system there, right? A minimum operating system should be available, and on top of it is a Java application, so we install Java and we install Tomcat, right? This is the stack team that is prerequisite before you deploy your application, which means that all the environments within your organization should have this pre-set up completely. This have pre-set up completely, right? And then once you have this one team, once you have these environments ready, then I worry about delivering my application code, right? This is the file, I take it. So here it is. Just give me a second, team. So here it is, team. We move the application here like this from development to QA and then pre-prod, and this is the production environment. Now this is where, team, we talked about the problem called as when I deploy this application in my QA, it was absolutely working fine. But when I deploy it into the production, it stopped working fine. It stopped working, right? Now, what is the problem here, team? Because we deployed the same application code, right? We deployed the same application code in the QA, it was working absolutely fine, where we tested successfully. But when we delivered the same application code into the production environment, it is not working. Now, what could be the reason here is that, team, let's say that in order to run my application, we are just delivering only the application code. But what about the dependencies here required to run this application, right? Let's say the time QA is being a development environment sometimes where you might have done some configuration changes, right? Where you done some term configuration, which is working with application absolutely fine. But when you carry this application into the production, did you carry that changes that you made it in the QA environment also or not? So there are some dependencies team, like your Java version, maybe a Tomcat version, maybe a operating system versions also sometimes matters. So any configuration files that you do it at the development environments, are you delivering only the application code or are you delivering all the dependencies also along with it? Now with this model team, we are just simply delivering our application code, but whereas my dependencies are configured separately, right? Which means that environment to environment, I need to copy over all the configurations whenever I do a deployment. That is a problem, right? How do I maintain, or how many servers do I need to copy the configurations? Now that is where, team, it is becoming a bigger problem here, right? That is where we are missing some configurations at the production. That is where the application fails to start or fails to run in a production environment where it absolutely works in the development. Because in the development, developer knows everything basically. He configures everything properly. He runs the application, absolutely works fine. He delivers the application, and where is the different team called as a deployment team or operation team who deploys into the production, where he doesn't know anything about it, but he just take the file from the developer, he deploys it. A developer gives set of instruction, he uses that one. If the developer forgot to give something, Okay, that's fine. It's a developer issue. Now let's say that developer has given everything but properly, but the operations guy, he forgot to copy something. That's an operation issue. Now there is a possibility that team, there are multiple issues here that happens basically, which is leading to the environment instability, or when is application instability, we call it, when you're doing in the production. Now, how do I resolve this issue, team? How do I resolve this issue? If you have some idea, team, so try to understand that if I want to deliver my application, I need some dependencies, right? I need all the dependencies. So why should I deliver only my application code? Why can't I deliver my all application dependencies? Now that is where, team, we talk about a concept called as container, right? The container concept, team, try to understand whatever it is, right? So here, team, we call it as when you want to prepare a container, let's say that why should I deliver my only application code? Let's say that here I'm writing something called as my app. Now I want to package everything into a single bundle. Let's say that in order to run my this one, I need Tomcat, I need Java, I need OS libraries. Whatever it is required by your application team, package it into a single bundle. Now, instead of delivering your only application code, let's deliver this entire application package, which has everything in it, right? Now, if I deploy this one, team, here, if it works fine here, then I'll move it on to this environment, right? So if it works here, then I move it on to here, so that I need not to maintain my configuration. It's each and every environment level, team, that is going to be eliminated completely. Now this is the advantage. So this is how it is, team, you can deliver it. Now if this bundle works in my development team, it must work in my production also. If it is not working in development, it will not work in production also, right? Now that is how, team, you can understand about a containers makes easier to deliver your application. Now the containers are the way to host your application, team. In order to run the containers, again, still we need a server, of course. We're not saying that our virtual machines are getting replaced with containers for sure. We're not going to replace them, right? But containers are a way to host application. If you come to the container definition, team, a definition of a container is that an application plus its dependencies, all of its dependencies packaged into single thing, that is called as a bundle. That bundle is called as your container. Again, team, uh, an application plus all of its dependencies packaged into a single bundle or a single package, that package is called as your container. So this is what is the concept of a container, team. That is where everybody is, getting a lot of benefits. It is one of the benefit, team. I'm talking about a container. What is a container basically? There are many other advantages that you get it with the containerization your application, containerizing your application basically. Many advantages that you get it. That is where we talk about this one. Okay, so this is how the container can be understood, team. Again, a container definition is that containers are lightweight, team. I'm saying that containers are lightweight. Containers are best suit for your hosting your microservices applications. Now that is where microservices and containers go hand in hand most of the time to ensure that your application delivery speeds up again, right? Now that is the advantage, team. We are talking about DevOps again. DevOps is all about speed of delivery and the stability in the delivery. That's what we are expecting it. So that is where the containers and microservices together helps us move our application into various environments with speed and then provides the stability also. That is where, team, whenever somebody talks about something called as DevOps, they always talk about various other technologies that need to be changed that will help us move with speed. Because, teams, earlier tools are absolutely working fine. They are stable. They are very good at performance also, but they are heavyweight and it is not helping you to move to the production faster. Now that is where people suggesting to adopt new technologies which are lightweight, which are going to be lightweight, which help us move to the production faster. That is what the goal of it DevOps always again, right? Now that's how, team, if you try to understand at the end, this is what is the goal of a DevOps, I call it. With waterfall, team, we delivered, like, we designed once, we coded once, and we tested once, and we delivered it once in 6 months. Now with agile, team, we designed, code tested, but we didn't deliver it. We designed, code test, multiple features were tested successfully, multiple features were developed, then you deliver it after 2 months sometime, right? That is what it is. Now with DevOps, team, we are expecting it to deliver it immediately, which means that whenever a feature is developed, design, code, test, deliver it. Design, code, test, deliver it. No wait for delivery. Immediately deliver it to the production. Whatever maybe the feature is ready, deliver it immediately. Now that is the goal of your DevOps team. That is where we talk about building a continuous integration and continuous delivery pipeline. Nothing but we call it as a CI/CD pipeline, right? So we talk about those things, team. Now, before that tools and technologies that we get into the things accordingly, what are all the tools that are we going to discuss as part of this course? How does they help us build me a CI/CD pipeline, which helps me move my application into production faster way? That is a goal, team. I hope you're all clear on what is DevOps now. Why do we need the DevOps? If you still have the question like why DevOps is required, team, because all organizations are today are working too hard to respond better and around changing market. We are looking for more dynamic changes which are happening in the market right now. Market needs are keen to adopt the DevOps practices, which helps us to be dynamic in the nature. That's what it is. Now all our nations are hiring DevOps engineering team who can work and adopt the dynamic market and needs easily. That is what it is. And in the last 1 year, team, we see a 75% growth in the DevOps engineers skills. Don't think like, team, you are not a DevOps engineer. If you're already working, you are a DevOps engineer, I call it, but you just need to be placed at the right position and you need to be collaborated as a DevOps team. That's it. Start working collaboration teams, start collaborating with your various teams, right? Do not working as sit in your team and sit in your, silo basically. You are a DevOps engineer already. Don't think like you're not a DevOps engineer. You are already a DevOps engineer, we call it, right? It is that you prove it as a DevOps engineer when you collaborate with other teams and understand the whole life cycle of your project. So that is what I say, team, to everybody. So don't look for a DevOps engineer role. Change the role structure from, from current role to the DevOps role. No, there is nothing as such. If you are working in an organization already, you are part of some team, then you are all known as a DevOps engineer already, right? It is just that stop looking into only your area, start expanding yourself into multiple areas and start working with multiple other teams, collaborate more with the different teams which are part of your project. Now that's when you are called as a DevOps engineer. That's when you called as a DevOps engineer. Again, we are not asking you to learn everything, just collaborate first of all. That's when you called as a DevOps engineer, right? So if you're looking for this one, team, again looking this one, there are many. Wait a second. Yeah, why DevOps? Again, this is what it is. So this is what is, team, we call it as why DevOps and everything. Now the DevOps certification that you're going to do it with DevopsUniversity, which is accepted by widely in the industry right now, and almost every organization will accept this one. Now this is just an introduction to the DevOps team. This is just an introduction to the DevOps I'm telling about it, right? Now as part of this DevOps course, team, we're going to talk about a few things. We're going to talk about a few things basically. Means what are the tools and technologies that we're going to use it to implement a CI/CD pipeline. As we say that as a DevOps engineer, you need to collaborate between multiple teams to work on various things accordingly. And again, as a DevOps engineer, you need not to learn everything, team. Don't get the misconception that you need to have or you need to learn end to end accordingly so to survive yourself. No, that is not there. It is that you need to collaborate first of all, and then you have your primary area always. Let's say that you are a developer, you are going to be a developer only. If you are a middleware engineer, you are going to be as a middleware engineer only. But stop looking into only your area, try to understand other areas also. So you will have your primary skill, team, whatever it is called as your primary skill, right? That is your primary skill, and the secondary skills are mandatory right now. So you need to expand yourself in learning multiple technologies, not a single technology. That is not going to work anymore. Now that is what is called as DevOps team. So as a DevOps engineer, you are expected to collaborate between multiple teams and have understanding of entire life cycle from the development to the production environment. Have an idea about it, how your application developed, how your application is deployed into various environments, and how you're delivered into production. Once it is delivered, how do I rectify some issues if there are something, maintain the product, how do you need to do it? Now this is all about your DevOps team. This is all about your DevOps. So let's get into a piece called as what are all the tools and technologies that we're going to discuss as part of this course today, right? So we're going to discuss about various tools, team, within this DevOps basically. We will start from understanding about the DevOps developers perspective, team. We'll start from the developer's point of view. So where he saves the source code. So we're going to start with learning the source code management tools or a version control systems. Simple things like Git is what we're going to learn it here. Let's say that Git and then GitHub. What is Git? GitHub, we're going to understand it. If you do not have an idea, so don't worry about it. We're going to discuss about them anyway. Git and GitHub, we're going to understand it. That is the first tool that we're going to learn as part of this course. Now, once the source code is available, once the source codes are completed, so we're going to build the code. For building the code, we're going to use build tools such as Maven, we call it. Within our course, we're going to learn about something called as Maven. There are various things we have it in the market, but we are going to make use of a Java project here to understand about the DevOps lifecycle completely. So we're going to use the Java project, which is the Java complete coding. In order to build a Java code, we use a Maven as a build tool to this one. But I'll talk about what is building code, why do we need to build code, everything. Just try to understand. Now we need to build a continuous integration pipelines team. So build automation is required for us. Build automations server for building a CI/CD, we call it. So build automation will help you to build a CI/CD pipeline, right? Now that is where we're going to talk about something called as Jenkins as a tool to implement a CI/CD process. Now, after that team, because we are in the containerization world right now, we need to understand about containers to host our application. So we're going to discuss about containers, containerization, we call it, right? Containerization tool, which is going to be your Docker, basically. That is what we're going to discuss about it. Now we're going to talk about something called as container orchestration. We need container orchestration for managing the containers because containers are a little bit dynamic again. We need a way to manage them well in the production. So we need a container orchestration where we're going to discuss about something called as Kubernetes a little bit, right? We'll touch base on the Kubernetes, how does container orchestration works and everything. Now after that team, we need to have understanding about how do I configure my infrastructure or how do I install something on a server. Let's say that, for example, if I have to install a Java across 1,000 servers, how do I do it? Now that is where we're going to talk about something called as configuration management. So configuration management is a tools which help us configure things where we talk about Ansible. Now with this team, we will conclude your operations part, deliver it into production. Now we get into the maintenance mode. With the maintenance mode, we're going to discuss about logging tools such as Splunk as an introduction. We do it. And we do have something called as monitoring tool where we're going to touch about Nagios, right? So this is how team you can understand about all these tools team. These are all the tools that I'm going to discuss about it within the course, right? So look at it, and if you have any doubts, or you can look at your curriculum again one more time. But these are the tools that we'll be touching in this course, and we'll try to understand about each and every tool, why it is, how it can be used within your DevOps lifecycle to implement the CI/CD pipeline, right? All these tools team which we're going to discuss as part of our course. Okay. Now this is just for a quick introduction team. I'm telling you these are the tools and technologies that we'll be going at. Right, these are tools and technologies that we're going at. Now in order to work with team, and I'm promising that again we are going to use it completely a practical oriented session here, means I'll be demonstrating everything practically more. Maybe we'll cover theory for 20 minutes, means that 20% of the theory and 80% will be practical. So everybody have to do practice. We're going to provide you necessary labs, necessary instructions, everything we're going to write, give you a written document for it. In the session team, please try to follow me and understand the concepts, and later you can follow the recording of the sessions and you can follow and execute your labs accordingly. That's when you can go ahead and practice the things, many things. If you have any questions, you can use our LinkedIn community to post your questions, so we'll always be there to help you, right? So all these things team, we're going to do it accordingly. That is what it is. Now with this understanding team, with this understanding, let's try to understand now how do I set up these tools and how do I work on these tools. So we need a machine team, we need a server or a Linux, because the DevOps tools are Linux friendly team. So we're going to discuss mostly on the Linux only. Everything will be on the Linux only most of the time. So here team, we need a server, basically a server in the sense a Linux machine, I call it. So what do I machine, or from where do I get it? This Linux machine. I hope we had a yesterday session team, I believe, right? We had you guys had a session yesterday about how do I create a server on AWS cloud. So we have shared a document with a clear instruction already yesterday with all the instruction. How do you set up a AWS account? AWS is a cloud team. It is a cloud service provider basically. within which you're going to procure a server, which is a Linux server, right? And then within which we're going to log into that Linux server, Linux machine, we call it. And then within which we're going to install each and every tool, and we will start practicing on them, right? With the yesterday session team, most of you might be clear already. How do I log into my account, or how do I create my AWS account? How do I log into it? How do I create a EC2 instance of Ubuntu team? Means we're going to use a Linux team, which is called as your Ubuntu. Mostly Ubuntu 18 is what we're going to do it. Ubuntu 18.04 LTS version of the operating system, with which we're going to understand about everything team. This is what all we're going to do it. Now here team, I think because you already aware of how do you create an instance, I'm not going to jump in directly, but I will just going to create an instance again one more time right now, just to make you clear on how do you do it. But if you still have issues in after this one, following this me, if there are some issues in following here, right, you can watch the recording and need to repeat the same thing, or let's say that you can post any queries and questions you have it if you do not understand anything within our LinkedIn community. So we will try to answer all of your questions through the LinkedIn community accordingly. Okay, now that is what it is team. So the next thing is that which I'm going to do is that right now we will get onto the AWS console and we'll try to show you how do I get instance and how do I connect to my AWS instance from my laptop. And then we're going to, once we log in there, we will try to understand how do you work on various tools accordingly. That is what all we're going to do it. Okay. Okay, so team, let's look into it right now. While I'm doing something here, I'm going to talk about AWS also, whatever is possible, right? Now, let's to be something team. Uh, coming back here, you can open your browser. Since AWS is a cloud service provider team, a cloud service provider usually gives a set of services such as infrastructure as a service and platform as a service and software as a service. Examples team, I'll come out from the software as a service, like for example, software as a service which you use it regularly is that a Gmail service, right? A Gmail is the software basically which is you're using it for free. Of course, there are many softwares that are used as your software as a service or paid versions also, right? So Gmail is nothing but a software as a service team which you use it. Means there are organizations who provides the software as a service. Likewise, cloud service provider also does some softwares as a service. If you would like to use them from the cloud service, you can use it accordingly. That is one type of a service. Then the second thing is called as your platform as a service. Platform as a service is something like whenever you want, for example, you want a server called as database server, but you don't need to worry about taking a machine, install the database, and check everything, maintenance, security patches for database, everything. I want to avoid all this nonsense, but I just want to have my database ready there. I want to put some data into database. Now that is called as a platform team, which is required by you for your hosting your application or your applications try to write the data. Now that thing we call it as platform as service. The cloud service provider does provide this cloud platform as service. Now out of which this one team, there is one very major thing, like 90% of the customers on the cloud uses this particular service called as infrastructure as a service. When I say infrastructure as a service team, which is nothing but your servers, like you're renting the servers and using the servers to host your various softwares and applications accordingly. Now that is what also team we're going to use it, which is nothing but infrastructure as a service we call it. So let's look into this one team, AWS console right now. Means I hope team you can create your accounts, a free tier account. If you do not have an account already, you can create a new AWS account within which AWS offers something a free tier account. So you can use a free tier account for all our lab practices team. You do not to worry about anything there. So once you create your account team, we can log into our account successfully by using the email that you used it. Next, it will ask you the password team. Just enter the password to log into your account. Right. Now, once you log into your account team, there is a various services which are offered by your AWS. Like I said, like infrastructure as a service or platform as a service, whatever it may be, right? Now here it is team. I'll say that when you go for this services tab on the top here, let's say that there are various services which are offered by your cloud will be displayed, AWS cloud. Now in which team there is something called as compute, storage. These are all comes under the infrastructure as a service. But if you go a little bit below, there is something called as database such as RDS, DynamoDB, everything, right? Cloud Trial. These are all called as a platform as a service, we call it, right? The platforms as a service, you do not need to worry about them. They will take care of everything. Now, finally, team, there is something, a software as a service also will be available here. Like some tools, they will allow you to do it accordingly. There are many things here we can use it accordingly, right? So here it is, team, in which we are actually going to use it, infrastructure as a service right now, within which I'm going to the compute section, where we are trying to create a EC2 instance. EC2, nothing but your elastic compute cloud, we call it, team. It is elastic, so you can get it whenever you want it. Now within this one, team, you will get to, or when you click on the EC2 service, you will be taken to the EC2 dashboard. That is what it is. Now within this one, team, try to understand, you need to go for the running instances, or let's say that if you go below also, running instances is something, team, where if there are any servers already running, it will display it here. Let's say that click on the running instances here. Right now, team, there are no instances. Don't confuse, team, whenever I say instance here, which I refer to a server, a Linux server basically that we wanted. Just like your laptop, some hardware, and you have an operating system, Windows operating system in it. Likewise, we need some hardware with capacity, and we have a Linux operating system installed. That is what we are trying to do it here. Okay. So here it is, team. When you click on the EC2, click on the services, click on the EC2, it will come to the EC2 dashboard page. Within the EC2 dashboard page, you will see the running instances link. Click on that, it will link it to this page that you're seeing it on my screen right now. Here, team, you click on the launch instance because you do not have anything as of now. Click on the launch instance. Now it will give you various servers, team, various type of operating system that you are requested. Now within which, team, we're gonna use something called as Ubuntu. On the top search bar, team, type Ubuntu, we call it. If you type search it, now you will see something called as Ubuntu 18.04 LTS, and which is a free tier eligible, team. Ensure that you select always the free tier eligible ones, right? And select it. Now here, team, we're going to use something called as a T2 micro again. This is only the free tier eligible, team. And as we are trying to use only the free tier services, if you use anything else, team, it is going to be charged for you. So ensure that you're not using anything else except the free tier one. With free tier, team, we get one CPU and then 1 GB RAM as free, which is going to be good enough for us. Most of our labs, we can use it accordingly. And let's say next, team, you can take out how many instances required, which is we require only one as of now. Let it be as it is. Add storage, the disk space that you wanted, which is 8 GB by default, leave it as it is. Need not to do anything here. Next, add tags, nothing to change here also, team. Do not do anything, right? Which is leave it as it is default. Now the next one is very important, team, which is called as configure security group. Now this is where, team, we will allow our server to be accessed by everywhere. Now here, team, what I'll do is that instead of create a new security group is an option, and then you can name your security group. Let's say that uh, du demo, I'll call it something, right? Whatever the name you want to give it, team, you can give it. Let's say that du demo, I'll call it. That is name of the security group is called as du demo. And within this one, team, there are certain rules that you need to keep it, which is going to be your SSH rule. SSH is a protocol to connect to your Linux servers. Now there is one more rule I'm going to add it, which is going to be your all traffic, team. Ensure that you put it because this is necessary for you to, because we're going to work on various tools. All those tools need to be required to open some set of port numbers for working with them. So I'm allowing all the traffic so that you will not face any issues. I would also request everybody to use this rule so that you would not face any issues while you're working with your tools accordingly. And under the source column, team, ensure that you select it anywhere, and both the rules anywhere and anywhere. That will help us again to ensure you will be able to access your software accordingly. So here it is, team. Once you do these two settings, ensure that you have these two settings, and then say that review and launch, and then say launch. Now here, team, it is going to ask you for the key pair, which means that it is kind of a password for your instance to log in. Let's say that I'm going to create a new key pair here. Right. For the first time, if you do, team, you must create a queue name key pair here. Du demo, we call it. Whatever the name you want, again, just give that name. So let's say that it is du demo, and download this key pair, team. So within this one, you see that this is downloaded right now. Ensure that the file is downloaded team, which is available here within this one. Let's say that du demo, which is available for me, which is good. Once you download the file successfully, let's go up and then say launch instance. Now, in order to connect to the instance system, or in order to connect to the server that we are creating, in order to connect to this server that we are creating, right, we need a client. Basically, we need a client that will help us connect into the server. Consider this one team, we need a client, right? Your browser is a client to connect, or get the details of your google.com or whatever it may be. Client and server will be there. Similarly, the server of our instance right now, our server is running in within the AWS data center, which is not your local laptop to access directly. So we need a client that will help us to connect to the server, log into the server, or log into a remote server basically, and then start working on the remote server accordingly. Now that is where team we talk about something called as here a SSH client, because whenever you're talking about connecting to a remote server, connected to a remote Linux server, we need something called as SSH protocol. So we need something called as SSH client team, or let's say that there is an option here on the top on the screen team. If you're seeing it again, there is option called as connect. If you click on the connect also, it will say that connection method, basically a standalone SSH client. You can use this one as standalone SSH client basically. So what is the standalone SSH client is that there are various tools, out of which something called as a git bash. I'm using it. So git bash is a tool team, we call it. Git bash is a kind of act as a SSH client here. So we can just going to download this which one. And once you download this one team, you can install it on your server, right? Now, once you install it on your Windows machine, you can use something called as git bash app. Once you download and install team, I hope you all know how to install something on a Windows machine. I'm not going with that process here, but this is what, once you download it, you install it. It is not to download a .exe file. Just double click on the .exe team and say next, 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 finish. Once it is finished the installation, go to your search bar and then type git bash. It will open the git bash app. Click on the git bash team. Now it is going to present you a terminal, basically a command line terminal. Now this is called as your SSH client. Now the terminal here, we are calling this as SSH client basically. Use this content. If you say SSH, basically it will try to usage, it will tell you something like this. Now when you see this one, this can be used as your SSH client actually. Now using this one team, I need to connect to my server. So we have downloaded a file basically, which is the key file, the .pem file that we downloaded. We must use that file to connect to the server team. So go to the folder where the file is exist. Let's say that cd downloads team, because that folder, the file was available under the downloads folder, ls-l du demo. Now you can see that my file is available here. ls-l is a command team just to list the contents. I hope you're all aware of this one. Now I hope you're all aware of a basic Linux commands also team. It is mandatory that you must have a basic Linux idea, basic Linux commands idea, that is mandatory here. Without that one, you cannot understand what we are doing it. So I would suggest everybody to start practicing the basic Linux commands if you are not already aware of it. But if you're already aware of it, that's well and good. If not, please start practicing the basic Linux commands. I'm going to provide a resource from where you can get it, all these commands accordingly. Okay. Now you have this file team. Now, how do I connect to my remote system is that, right? How do I connect to my remote system is that within the AWS console team, look at this one. There is a command under the example. If you want to connect to the server team, I'm showing you again. If you want to connect to the server, select the server, click on the connect option. Under the connect option, example section, there is a command here, which is ssh-i, the file name that you have it. And Ubuntu is a default username team. And you can connect to this one accordingly, right? This is all I'm doing it. Copy this command and use this one here. If I hit this one team, or instead of this long DNS name team, I could replace this with my public IP address also. Simply here. So you select this simple public IP address of your EC2 instance. This is also you could do it, right? So I can replace this entire string with my simple IP address, Ubuntu @IP address, public IP address only, you must use it always, and then enter team and say yes. When you say yes, team, it will log into your instance successfully. Now, right now, team, we are inside our Ubuntu instance. Here I'm doing it. We are under the Ubuntu instance. Just to validate that, team, let's say that cat etc os release. Cat is a Linux command, team. Cat is a Linux command basically, which is going to display the content of a file. So here it is for me. This OS release is the team kind of a file which maintains what version of OS you're using it, all the stuff. So it says that name is Ubuntu and the version is 1804 LTS. This is the version we are using it, correct? Now this is your operating system information, team. That's what you do it. Consider that, team, you logged into your system as a normal user. As a normal user always, Ubuntu is a very normal user, team, when you log into the system. But with a Ubuntu user, we may not be able to perform many operations within our server. So we always have to switch to a root user. That is what I would suggest everybody, to not to have any permission issues while doing something on your system. Let's say that there is a command, team, here called as a sudo su hyphen, which let us switch to the root user, right? Sudo is a super user permission, team. Switch user we call it. Sudo is a super, like we are switching to the administrator user, you may think about it. So Ubuntu is a normal user. Now I switch it to the administrator user on my local. This is called as root user in Linux. Now this have a super privileges, team. You can do anything on your system. Like you can install something, you can uninstall something, you can crack something within the system. You can do whatever you want it with the root user. But when you run it as a Ubuntu user, team, you may not have enough permissions to install a software or uninstall a software, or to do some necessary task also. You may not have necessary permissions. Now that is where, team, I'm suggesting everybody to switch to a root user before you do anything. Once you log in with your Ubuntu user successfully, so just to show you the, team, let me say that again. I'm coming back to my git bash terminal here, which is my Windows git bash terminal. Nourish for something. If I want to log in, team, I use a command called as ssh-i, the PEM file that you downloaded, and the username of your system. That is what you use it, and at the rate IP address of your system, which is going to be a public IP address. Use this, hit enter. It is going to log you in to the server accordingly. Now, once you log into the server, team, since you logged in as a Ubuntu user, which is a very normal user, which requires an escalated permissions to do some operations within your system. So what I would suggest is that you switch to the root user always with a command called as sudo su hyphen, right? Now, this is all what you need to do, team. Once you switch to the root user, right, once we switch to the root user, we could do anything on our system. Even you can crash your system also if you'd like to. That kind of a permission that you have it with root user. Be careful about it when you're deleting something or creating something accordingly. So you must be aware of what you're doing on this thing. Now this is a very basic Linux, team, I'm talking about it. But if you're not aware of the basic Linux commands, again, I think we already shared a repository with you guys, I believe, right? Within the GoToWebinar chat window, you will find the link, team, which is a repository, which is a GitHub repository, we got it. Now this is where, team, we are maintaining all our lab information, whatever the labs that you need to practice it, the instructions, the step-by-step instruction for installation, step-by-step instruction for your execution of labs, everything is present under this particular repository, right? I'm going to share it one more time, team, and if you have it or not, just make a note of this one accordingly. Okay, so we're going to share it one more time, entire audience, right? Ensure that you save this link, team, with you all. So which is where you will find all the technologies that we're going to discuss. For every technology, whatever the instruction that you needed, go for it accordingly. Now, as a basic, team, as we're talking about, as a basic, you must have a Linux knowledge. Of course, we're not touching on the Linux here, but as a basic Linux, you need to have a basic Linux knowledge. We kept some Linux basic knowledge instruction here. So please use this document. Please use document. We kept it all the necessary basic instructions or basic commands that you need it on your Linux to know, right? I want everybody to practice these things if you are not already aware of it. If you're already aware of it, team, well and good. Please follow along with me. For those who do not know these things, the basic Linux commands, I would strongly request or recommend, go through this document and execute each and every command and try to understand each and every command before that one. So this is what all you need to do it accordingly. Okay, So ensure that team you go with this document and ensure this, because these are the regular commands from now onwards. We're going to use it. As I told, like we will be doing theory 20%, 80% practical. So when I'm doing implementing the practicals, I'll be using all these command line utilities or commands basically within my Linux systems to make you understand the concepts accordingly. So I would strongly recommend again everybody follow this document, maybe run through once at least, and ensure that you can do it. This is just a suggestion team, so please go ahead. We're not touching here with the Linux. This is just for your information only, we kept it. So please go with it according. I think we already shared some Linux basic videos also with you guys. So please follow those videos also to make you understand about the Linux accordingly. Now this is about a team. We now understood that what is DevOps. Just for a quick recap team, we started with the very basic definitions of server and application, right? And we understood about software engineering, software development lifecycle phases, right? So what are the various software development lifecycle we using it? Now, which we touched about the evolution of ITs, waterfall, then agile, and then we discussed about DevOps, why DevOps is required, or what are the goals of DevOps basically, right? Now, once after that one team, we also requested, we try to understand various terminologies such as monolithic architecture, NTR architecture, and microservices. What is a physical server, what is a virtual server, what is a container. We understood those things also. And what is a data center, what is a hosted data center, and what is a cloud environment, which help us right now within the DevOps world team. Right now we have something called as, within the DevOps world, we're using something called as microservices, containers, and the cloud, which are helping a DevOps to deliver your application faster into the market. The only goal of your DevOps is that deliver your application as soon as it is ready. Do not wait for to be delivered. That is what the goal team, which means called as faster. Along with that, we also need to achieve the stability. So this is just a quick recap team. And then after that, we try to understand tools and technologies that we're going to discuss, various tools and technologies. Then we try to understand the EC2, the Amazon cloud. What are the various services offered by the cloud? Right, and then we're going to use a compute service or infrastructure as a service, within which we try to understand how do I create an EC2 instance, and then how do I log into my EC2 instance. Now this is all the things team that we understood so far. This is a very basic session again. So these are all the things that we discussed so far. Hope you're all clear on these things team. So let's do something here now. Let's try to set up something which is going to be your the first and foremost tool. The first and foremost tool here, which is going to be your Git team. That is what I'm going to discuss about it. So when I'm talking about this, as in the tools team, as I said, like we'll be starting from the developer standpoint. What are the tools which is used by the developer? So how he's going to maintain the source code, and then how he will be able to give us the information on the source code accordingly. We'll try to understand the tool called as Git team. Git is called as your source code management tool, right? A source code management tool or version control system, we call it. So we'll try to understand it. First of all, what is version control system and why do we need this version control system accordingly, right? So just a minute team, I'll just give you the introduction to the version control system and what are version control system tools. We use it regularly, right? So just give me a second team. Yeah. So here team, I'm just opening up something here. We're going to talk about something called as a version control system or called as source code management, in which we are going to talk about something called as Git. Now Git is a version control system team or called as source code management tool, which help us manage our source code somewhere. Now what is managing by the source code team here is that a version, basically try to understand. A version is nothing but a number that is assigned to a software whenever you release into it. Let's say that I talked about something called as iOS 13, right? Why it is called as iOS 13? Basically, what was the previous version called as iOS 12? What were the changes done from one version to other version team, one number to other number? So we keep on releasing the features day by day. We are keep on adding functionalities to our software team. Those are called as, we maintain them changes. We maintain the changes or we track the changes, we call it. The version numbers are usually used to track the changes team. That is what we call it always. So version is always to track the changes. What is that mean, team, again? Whenever I say version 12 is upgraded to version 13, now what is the differences between 12 and 13? To track these changes, we're just hiding with these numbers. That's all we're gonna do it. Now this is what you call a team. In organizations, whenever you see it, basically you do see various numbers like 13.1.4. I'm not sure how many of you observe the version of a software always, which always comprises of your multiple digits. Like whenever I say now iOS version, which is going to be 13.1.4 something, some long number, not a straightforward number, but it is combination of multiple digits with a dot separated, right? Now, what are these numbers, team, and why do you use it basically? If you try to understand about the software lifecycle here again, whenever we keep on working on software changes, team. So let's say that there is something called as a version released into the production. 13th version is released, 13.0.0 is the version which is released into the production. Now the client started reporting some serious issue. You want to fix it immediately, team. Now that fix, we call it as a hot fix. Let's say that there is an immediate fix requested by the client, which is hampering the functionality of a software basically. The client requested that need to be fixed immediately, and it need to be deployed immediately once after it is fixed. No waiting, right? Now that changes, team, that is a simple change, or it can be a simple change or whatever it may be. Whatever it is requested by the client that need to be deployed immediately, we call that as a hot fix, right? A hot fix, team, is always that a change that is requested by the client to be fixed it immediately and then deployed immediately to the production. And that is when, team, you see that the last digit gets changed. Let's say that instead of 0 now we change it to 4, right? Now that is what it is. We released 13.0.0, but after releasing that one there was a bug that is reported by the client. We fixed it, we delivered it immediately. Now that is a simple bug fix, team, called as this one called as hot fix also. Now that is where we change the number to the last number basically. That's what. Now let's say that, team, the second number which is called as 1 here. Now when do I change this number? What is the category? What is a thing that we need to change this number, right? Now in this strategy, team, in this basically, let's say that there is couple of bug fixes reported by the client. Let's say that there are multiple bugs which are reported by the client basically, but those are not stopping the application to be used by the user. They're all using the application, but they're not really causing any harm in accessing the application, right? Now that's when, team, there are multiple bugs that need to be fixed. Along with that, I want to release a feature, one feature I want to release it. Now all these bundled together into a single release. Now that release is, we call it as a minor release basically, right? Hot fix release or minor release, we call it accordingly. Now the last number, team, that is called as 13 basically. Now this is whenever you change this number basically, we call that as a major release, which means that there is a major impact coming to the software that you're developing it or delivering it to the end user. Maybe the entire interface of the application is getting changed. There are n number of new functionalities will be added to the software, and the entire visualizations that you do it, and maybe the performance of the system completely changed over this run, right? Then that we call it as a major release accordingly. Now this is how, team, we keep the version numbers to track the changes based on the criticality of release that you're using it. We keep on changing the numbers according to our requirement. Now that is where we talk about something called as major release, minor release, hotfix release. These are all the general terms that you hear it in every organization whenever they are delivering their application into the various environments accordingly, right? Now this is what it is called as version, team. What is a version? Is that version will help you to track the changes of your software over the years or over the releases that you do it. Within multiple releases, what were the changes happening to the software? That will be tracked with a version number. Version number always help us to track the changes between multiple areas. That's what. Now, team, that's good. You understood about the version simply, but how do I track these changes? How do I help, or what tools will help me to track these changes accordingly? Should I do it manually? Let's say that I have a program, I changed a line. Okay, this line got changed. Should I note it manually there? No, right? If it is going to note it manually, then I need to hire a separate person who tracks these changes only separately every day. Now that is not how, team, we do it. We take a server again, or we take a tool basically. Now that tool is called as your version control system, right? Version control tool, source code management tool, version control system. All these are the tools which help us to track the changes of a software, right? That is what we're going to do it. Now over the years, team, again, because we are evolving ourselves, over the years, over the decades, from the time inception of your computers into the market. So here team, we used various types of version control system, right? So how do we track the changes? That is nothing but the version control system will help you. Now over the years, basically, we are using various technologies, various tools, basically various types of version control systems to help us do this one. Now the first type is called as your local version control system team. So likewise, you had waterfall, agile, and DevOps. Now within this one, we also have something called as local version control system, right? Now this version control system team is going to help you the version changes, but this is going to be installed only on the developer machine. Now when I say installed on the developer machine team, developers usually get a desktop or a laptop to work on their things accordingly. So within their machine itself, this tool will be installed within his machine. As long as he is making the changes, the software, the tool that you installed will stop or start tracking the changes accordingly continuously. Now this is what it is team, we call it. That is what we call it here. Now, when we talk about this one, developer's laptop, local version control, so what are the limitations of this? What are the disadvantages of this one? Which is moved to the next one. Now, with local version control system team, the problem is that if my developer's laptop is crashed, I will lose all my changes. That is the first point. Now, the second point is that if there are multiple developers working on the same project, this is a single project. Developer one is working on feature one, developer two is working on feature two, right? Let's say that they are keeping track of changes in their local machine itself, but when you want to deliver this application, you want to deliver it as a single system, right? Single application. Now when you want to integrate these multiple features into a single application, now where do I track the changes again? Where do we track the changes? That is again a big problem, which means that team, the collaboration between multiple people, multiple developers to track the changes as a single entity is not possible again. Now that is a problem team that we see it normally with a local version control system. So in order to avoid or in order to overcome these limitations or the issues with the local version control systems, we created a new type of version control system, which is called as your centralized version control system, right? We call it as a centralized version control system team. That is what you can think about it. This was local, the red, right? Now you have this centralized version control system team, which means that instead of installing a tool on your local machines, now we took a centralized server here and then we are installing on the centralized server. Let's say that team a Gmail, right? A Google Drive, think about it. A Google Drive is a place where you store all the files. Now Google Drive also follows some versioning team when you do it. I'm not sure how many of you observe it, right? So Google Drive is like a centralized place where I put all my code. Now that is responsible for my maintaining the versions of the code accordingly. The tool is centralized completely. Now every developer will connect to the centralized version control systems. He make a copy of the source code into his local. He will work on his local machine completely, right? Then whenever he feels that he need to create a version, he will simply upload, right? He will simply upload his code into the centralized server. Whenever he uploads a team, here it is going to create a version accordingly. Now that is when we call it as centralized version control system works, right? Now this is how team you can think about it. This is what it is working. Likewise team, because it's a centralized server right now, I can share the same repository with multiple people. Multiple people can take a copy. Multiple people can push the same changes to the multiple, the repository. Entire versions are maintained in the centralized repository itself, right? Now that's how you get the advantage team here, is that a collaboration between multiple developers is very much easier. Need not to worry about maintaining the changes within their local machines. How do I integrate it? No, that is not there anymore. So within the centralized server, it is going to track the changes from every developer who pushes the changes into the centralized server. That is advantage. But what are the disadvantages here again? If you think about it, what happens if my centralized is gone, right? What happens if my centralized server is down, right? That is one problem. You may see it sometimes. Let's say that if you have backups, that's good, but if you do not have a backup, then I will lose the entire version history again, right? If I want to roll back the changes to a particular version team again, I will not be able to do it. I will lose the entire version history again. That is again still a problem here. That is one problem, we call it. Now again here, the developers are dependent on the centralized server. If the centralized server is not available, developer cannot do any version changes. He has to sit idle again. Now that is another problem. So that also need to be resolved again, right? So Of course, team centralized version control systems were there for a decade, basically, right? We used it very extensively. The SVN was one of the example there, subversion we call it, and CVS was one of the example, right? There are many things called as many other tools like what do you call Perf something. I believe there are many other tools which is there as a centralized version control systems. TFS is one of those version control systems, right? There are many tools, team, which you have it as a centralized version control system in the market. People are still using this one, but right now in the market, everybody started using the latest technology. That is nothing but the next one, team. Now you understood, team. If the centralized server is gone, I cannot get my version history again until unless you maintain the backups, right? If you maintain the backups, of course you can restore it, but if you lose everything, we'll lose everything again. Now that is where, team, we see that and developers are dependent on the centralized server to create a version. So the network dependency is available to create a version, which is a slower things which you call it, means it is going to work in a slow direction. The developer's productivity may not be that effective with a slower responsive systems, basically. That's what is a problem that you get it. Now this is what is called as your centralized version control system, team, which help us maintain the versions of the source code, but still they have some limitations or challenges with this. Now that is where, team, we started discussing about the latest technology or latest version control system, which is called as your distributed version control system, right? Now this is called as your distributed version control system, team. Try to understand. So this is very much important here. How does the distributed version control system works and how does it help us makes the developers productivity more, and along with that, it is also maintain the version history safe always. Now think about, team, we are thinking about a single local server, thinking about the centralized server. Now we distributed is nothing but a combination of your local plus VCS, so local plus centralized, can be called as a hybrid, this one, right? Now what happening here is that, team, just like your centralized server, we still have a centralized server here. Centralized version control system is available, within which we'll always have the versioning maintained by this version control system. Let's say that, team, under the centralized system, I have my repo page and I created something called as v1 v2, the version history being tracked there, right? Within the centralized system, team, the version history tracked only on the centralized server. Now in the distributed version control system, the version history is maintained on the centralized server, and whenever you make a copy of the centralized repository to your local machine or developer makes a copy of it, now he will get all the version history in his local machine also, which means that he is going to maintain a local repository here, right? Which help him to maintain the version history in the local, which means that, team, the version history is maintained at multiple locations here. One copy in the centralized server, one copy in the developer machine. Likewise, if you have 10 developers, 10 developers will have their own copies of the versions accordingly. So every developer is having a version copy so that it is that I could restore it. If my centralized server is gone, I can restore it from my any of the developers accordingly. If one of the developer loses it, he can get it from the central accordingly. So this is called as, team, distributed version control system. The version history is maintained at the centralized server as well as your developer's machine always, so that you need not to worry about losing the version history here. Version history is always safe, at least one or the other systems. But if you're having a bad day and then everyone lost the thing, now I cannot help with it again, right? Now if you have that bad day, then I cannot help with it. But at the end of the day, it is a possibility that since you have the version history at multiple locations, distributed structure, distributed the version history into multiple systems, I have a flexibility that I can restore it from wherever I want it again. So it will be easy for me. Now, since, team, we are committing the versions or we are creating the versions in the local itself, or whenever the developer is working on the source code change, if he wants to create a version, he can create everything in the local itself, right? Once he does every changes in the local, team, once he does all the changes in the local, now that is when he will upload the changes to the centralized server. Now this server will create the version accordingly, right? Let's say that v6 something. Now you create a v6 first here, team. Let's say that you will have v5 and v6 here. Developer creates the version here first of all. Let's say that v5 and v6. Once he creates the version in the local, then he will go and upload it to the centralized server, team. That is what you're gonna do it. So centralized server will maintain the version history, so that local version also will have the maintain the history. So here team, you do not need to depend on the centralized server for creating a version, so that it will be easy for the developer to create the version in the local, which improves the productivity of your developer again accordingly. Now these are the advantages team that you get it distributed version control system. Now if you try to understand about it, right, what is Git and what is GitHub, a lot of people have a lot of confusion here. So in order to maintain the local repository team, we need to install a client tool, which is called as your Git client, a Git software that we call it, right? Now, in order to maintain the same version history team on the remote repository or a centralized server, the centralized server is called as your GitHub. Okay. GitHub is a public repository team. I think we shared a public repository for you right now for all the labs. So GitHub is a public source code repository team where you could save entire your source code accordingly, right? You could create your account, a private account, public account basically. So once you create your account on the GitHub, you could maintain your source code within the GitHub account. It means that I will make some changes in my local, or let's say that if I'm a developer, I will install my Git client on my local server. I can create a repository in the local. I can maintain everything in my local itself. Since I want to collaborate with multiple people, so let me upload my changes into centralized server so that the version history will be maintained in the centralized server, a remote server we call it, as well as in the local, right? That's when we call this as a Git one. Now to maintain the version history in the local team, we use a client called as Git client. Now the central server is nothing but you call it as GitHub. So we're going to work on both of them team practically, but I'm just telling the theory part here. The GitHub is something you do it. Now, once you have this one team, GitHub is public, but within your organization, if you want to go for a centralized server private solution, there are many solutions such as Bitbucket, which is a private repository, and GitLab is also a private repository, which you can maintain within your organization behind your firewalls so that nobody will be able to access your source code accordingly. Now, this is what it is, team. We call it as version control system, and how do I, or what are the different types of version control systems? This is what we call it about it. Now with this understanding team, with this understanding, let's try to work practically on this tool team, which is going to be Git. So consider that team right now, consider that you have a version, consider that right now you are a developer. Consider that you are a developer right now, you have your machine, right? This is nothing but your EC2 instance team or Ubuntu instance that you created right now. So this is your developer. So consider that you are a developer, right? So we're going to install a client utility is called as Git client here on my Ubuntu instance. That is what I'm going to do it. So let's try to look at team. How do I install my Git instance here, Git client software? Then we'll try to look at it. Now I'm coming back to my system team here. This is my server. I call it Ubuntu instance. So how do I install my Git software on my instance so that I could start working on my Git accordingly? Let's see that. So it is stuck team. Just give me a second. So let me relog into the instance. Maybe it is kind of session timeout team. If you don't access it for your instance for a while, it is going to session timeout. So we'll log into, or whenever the session times out, you need to relog into the instance again. Let's say that I'm logging into my EC2 instance again. I logged in successfully. Now I will switch to the root user team because I would like to install something here. So whenever you want to install something, I would recommend everybody to be a root user so that you will not face any permission issues accordingly. Now all the instructions are available within the repository which we share team. Please make use of this repository, which is DevOpsUniversity DU under the GitHub. So we're going to understand this accordingly. Within this one team, there is a folder called as Git. So all the labs are available for you here. So here it is. Let's say that install and configure Git. Open this file team. So you will see something called as installation instruction. How do you install the Git on your Ubuntu OS? Look at this, you have it. Now you can run these commands team, a sudo apt-get, whatever it may be. So these are the installation instruction team. If you are looking at this, what is this command doing here, which is apt-get is a package manager using which I can download a software in Linux and install a software, and which is specific for your Ubuntu instance again. apt-get is called as package manager, which gets the software which you requested and will try to install it accordingly. That is what all it is doing it. So this is a prerequisite team before you install your Git software basically. let's say that I will run this command here, copy paste team, just copy paste the things, so which is going to work out accordingly. So here we are adding a repository from where I can download my software, which is PPA Python package repository, we call it. So now once that is done, team, we will simply do an update once, so that it will connect to the necessary repositories again. Done. So once this is done, so we can install the Git software team, apt-get install Git. That is what all I'm trying to do it. So here it is, right? So once you install this software team, we can start working with this software accordingly, right? So I'll just show you team, how do I install today, so you can, from tomorrow we will start working on it mostly here. So here it is team, once we install the software, basically the installation is completed. You need to go through this output team if there are any errors or not. Right now I do not see any errors here, which means that my software is installed successfully. Sometimes it may fail also. You must check the output cleanly here. Right now it is good itself. Now once I install my software team here, which is called as git -- version, right? Now you can see that team, the latest version of Git is installed right now, which is called as 2.27.0. Now you can see this instruction team, we have successfully installed our Git software. Now, as I tell team, this is nothing but a developer machine. Think about it. Again, I'm telling you, you are working as a developer right now. We just installed something called as Git client, which means that I could do everything, version history or track version changes within my local system. That is what we're going to do it. Now once you're done with the changes team, we're going to upload into a centralized repository or a remote repository. In this case, once you create your team, we're going to upload it here, which is nothing but your GitHub. Okay, so this is what we're going to do it. So first of all team, as I'm telling it, we're going to work on the Git local repository completely, try to understand. Once we're done with this, and we'll try to move the code onto the centralized or remote repository. How do I do this? What are the various commands that you need to learn it? Yes, of course, everything we're going to work it practically. I'm going to show it. So like, as I told, like, I think 20 minutes we discussed theory, but next 1 hour or 1.5 hour, we're going to work on completely on the Git practicals. So with this understanding team here, I'm stopping here today. I'm not touching any of the practical things today. So tomorrow we're going to start with the practical mode completely. So what is, or how do you work with Git and everything, we're going to work on it. So that is what all we can understand. So today team, I hope you all understood the basics of DevOps. What is DevOps, why do we require it, and then what is the basic of version control systems. I just discussed theory again. From tomorrow onwards, we're going to work on it. So we're going to save and share all the things for your team. So whatever is necessary, whatever is the necessary things here, whatever you're requesting it, everything we're going to share it. I think we already shared about the lab switch instruction you needed. So I would request everybody to go through this lab repository, right? And then go through this Git and installing a team, try to install the Git by tomorrow. So try to create a EC2 instance, try to install the Git and keep it ready so we can work on the things accordingly. Okay. So that is all for today team. I hope you enjoyed the session. So I'll stop here and I'm open for questions right now. So if you have any questions, please do let me know. We can discuss them accordingly, then we can wind up the session. Any questions team, anybody have it? So please do let me know.
Hi Naresh.
Hi.
This is Teresa here. I tried to do the AWS and install Git. I'm stuck a bit. What happened was I accidentally opened the PEM file. It opened in Explorer. Now I think it changed its format. And when I try to go back and obviously do the launch bit in Git bash, it doesn't recognize the file anymore.
Okay, okay. So means that your file may be corrupted there. So in this case, right, what we can do is that we cannot regain that file. That is not possible for us. In other words, you need to open a ticket with AWS so that they can give you a new file with that same thing. What I would suggest is that create a separate instance and create a new PEM file, and then try to log into the new instance. I think I
Can I
show
do
you
that?
how to. Yeah, you can do that. So I think you created your instance is running right now. What you do is that you do not want to use this instance anymore. So go to the actions, go to the instance state and terminate it. So once you terminate it, this instance will be gone, and you can repeat the same steps again with launch instance. Now at the end again, you can create a new key pair and then use the new key pair to log in carefully. Okay.
I will. Yesterday, the instructor suggested that we save it in a safe location. That's what I was basically trying to do. Is it better not to move it then?
Yeah, it's better not to move it, right? It's better to save it in the same location. And like I saved in my downloads folder always, like I have a PEM file here. So keep it there, or you can move it to a different location also, that's fine. But keep it there wherever it is there. That should be recommended always. Should be
Sure,
good enough.
Naresh. I'm on this page where launch instance is there, and I can see my instance. It's running. If I click on,
Select the instance,
okay, I
select
have,
it,
yeah,
and
yeah,
go to the actions,
okay,
instance state, and terminate. Okay.
terminate. Okay,
Yeah. And then
all
recreate
done.
a new. Okay. Great.
Excellent. I'll do that. Thank you.
Thank you.
Hi Naresh, Bala here.
Hi. Hi, Vala.
Hi Naresh. Actually, yesterday I believe after the session I installed Ubuntu 16 and then installed Java and Maven. So
Okay.
you recommend to use Ubuntu 18, right? So should I terminate the current instance and then create one other, or is that fine to continue?
That would be fine to continue, but if you want to be intact with me, you can terminate that and create a 1804. That will be, but 1604 is outdated right now. You will not get any updates. If you try to install the latest software, the Ubuntu operating system may not support sometimes. So I would suggest to go with 1804 itself, which is compatible with all the latest software that we're going to install it. So just terminate that one and create another one. That's okay. Okay.
Oh, okay. Yeah. And on top of that, I have installed Java and Maven, right? So that is required as well, right?
Now that you will do it as we go on. Right now we are learning the Git only. So right now you could
Oh,
install
okay.
Git and practice along with Git. And then once we're done with Git, I will tell you when you to install the Java and Maven and everything accordingly. Okay. We'll go step by
Yep.
step.
Sure, nice. Thanks. Yep.
Great. Yes. Yeah.
Hello.
Yes, please tell me.
Yeah. Actually, I have one question on this. We install Git, right? So it is like related to a local GitHub or a Git repository, or I mean, it is like we install a GitHub. So what we
No, we
install?
did not install a GitHub. We just installed a Git client. Okay, Git client
Okay.
will help you to maintain the repository in the local. That is what all is going to do it. Now, Git client will help you upload your source code from your local machine into a GitHub repository. That is called as a remote repository, and Git client will help you maintain the local repository. We're going to create a local repository. We'll work on the local repository first of all. We'll try to understand the changes within the local repository. How does it track the changes, everything. Once we done or create multiple versions in the local, we'll try to upload or push them into the centralized repository so that we could collaborate with multiple developers accordingly within our organization or within your team accordingly. That is what we're going to do it. Anyway, we'll work on that one tomorrow, so you will understand them clearly for sure.
Okay. Thank you. Thank you.
Sure. Yes. Any more questions? Okay, so team, if you all have no more questions, thank you so much. Hope you all enjoyed the session
Hello.
today. So, yeah.
Hello.
Hi.
This is Manoj. I joined a little bit later. My question is, what is the difference between the GitHub and GitLab? You said, Bitbucket and GitLab. So what is
GitHub is public, right? Whenever I'm saying github.com, right? Those who have an internet connectivity, they can go ahead and check this one, right? There are many things available within the GitHub. It is kind of a repository which is publicly available. Those who can connect to internet, everybody can look at it. If I put my source code here, you will be able to take it and you can use it for your own purpose, right? That is called as public. So if I want to maintain it for private and I don't want to put it public, I want to install it within my organization. Now the same thing which will install it behind our firewall, the software is called as your Bitbucket or GitLab. Those are the private solutions we have it that you will not charge them account. That's all going to do it. Okay. That will be available only for your organization.
Okay. So we have to buy that and then install it.
Correct.
Or is it open source?
Yeah, no, it is not open source. They have to purchase them. Okay, those are private solutions with our licensed ones.
Oh, okay. All right. Okay, all right. Thank you.
Sure.
Hi, Naresh. This is Rahul.
Hi, Rahul.
So, when can we expect these online recording sessions? Actually,
I think I would leave that question to the DU folks because I'm just a trainer here. They will upload it in a couple of hours, I believe, mostly.
Okay, because yesterday also they they have not uploaded actually.
Oh.
No, yesterday also we have sent the email to everyone, and within a 4 hours time frame, we are uploading and sending the email to everyone.
Okay, but I haven't received any email actually. So
please ping your email ID, so I'll make sure we'll be getting all the recording session.
Okay.
Yeah, please ping your email ID to the panelist, Rahul, so they'll be able to make it happen. Okay.
Yeah, sure. Thanks.
Hi, hi, Naresh.
Hi.
Hi, this is Gautam here. So just requesting if you could share the PPT that you were showing earlier in the session, that would be helpful.
Yeah, you will get that. So you will get all the links. I think Kumar will share you all those things linked with you. So you'll get all the PPTs and everything. Okay.
Okay, great. Thank you.
Sure. Any other questions? Okay, so great team. Thank you so much. Again, I'll see you tomorrow sharp. Please do join on the sharp so we can start the time on sharp. Okay. That's all for today. Have a great day ahead or have a great evening. So we'll see you tomorrow. Take care.